Yeah. morning, everyone. Welcome to the second day of the RSC 19th Annual Symposium. So I'm excited to get started and pass this over to our moderator for this session. I just wanted to let everybody know that there will be a tour of the Trek Natural History Museum in the basement at 6 p.m. tonight, right at the beginning of our social. And so anyone interested may sign up at the museum's display table, which is right outside our doorway here. And I'm going to pass it over now to John Titus, who is retired from SUNY Fredonia, but was a longtime board member of the RSC, and we're excited to have him joining us and helping with our symposium this year. John?
Hello, thanks for coming. And we have a lineup of 4 great talks. So our first talk is Holistic Urban Land Reclamation, Incorporating Landscape Literacy. And speaker is Maurice Grundy. So ready to go.
Humble myself up here. Thanks, John.
Sure, thank you.
Hi, good morning, everybody. So as John introduced, my name is Maurice. I'm the Executive Director of the Lyceum at Silo City. I'm going to leave the explanation for what that is for the presentation, so I'll just get started. All right, so first I'm going to introduce Silo City as a location to you. I'm going to talk about the pre-colonial and industrial history of the site. Then I'll talk about how it became abandoned and reimagined as a new space. I'll then introduce the Lyceum at Silo City and talk about our native plant nursery and our connection to environmental literacy there. Okay, so where is Silo City? So Silo City is located in Buffalo, New York. So this is a view from the river. We are on the Buffalo River. We're in Buffalo, New York, and you can see in that EPA map on this side, on your, I guess your right, that this is the Buffalo River that winds directly down into Lake Erie, and we are directly on the Buffalo River and a stone's throw to Lake Erie, so we are surrounded by water. I zoomed in for you so that you can see this is of importance. We're just above Tift Nature Preserve, so we are neighbors with the largest urban nature preserve and also a space that's important to us. And that's us located right there, so we're actually that whole outer bend there. And this is an aerial view. The reason I'm kind of grounding you here is that this site was a grain storage and processing facility. And on this space, there are different buildings. Does this have a laser on it, or should I just point? The top one or the middle? Ah, thank you. Thanks. Got it. So I just wanted to note here, so across the, so this is us here, this is Silo City. I zoomed in, and you can kind of see that there are some groups of grain silos. I am going to actually show you what those grain silos look like and what they did. But I wanted to show here that as the Buffalo River curves around, you see that there's actually buildings along the whole way. So there's very few areas that are not covered by riprap, so large rocks, or not armored, covered by metal. And so we have some spaces that are special here, and I just wanted to point out this here. The entire acreage of the site itself is 27 acres, so we have 27 acres in the city of Buffalo located on the Buffalo River with some areas that are not armored. So we kind of have this kind of unique placing in the city of Buffalo. Now this was important because, I'm gonna go back one. So these are the silos themselves, and they would have been filled with grain. So grain would have come by ship down the Buffalo River and later by train as well. Grain would have been dropped off in these places. They would have been filled and stored. There was also milling going on here. So for bread and beer, there would have been malting processes also on site as well. And so they say this was, these were built in the late 1800s, early 1900s, and they became defunct probably in the 50s and 60s. They started to change. because of other trade routes, which I will also get to. So we now have this site where post-industrial reclamation has happened, the industry dies out, there's these monoliths left behind, and we wanted to take advantage. But before we were able to do that, I do like to take a moment and talk about the pre-colonial history. So before white folks showed up to this area, who was there? So this is an indigenous area where Haudenosaunee people historically and currently live. The area that Silo City is located on that Buffalo River would have had riparian and upland zone, would have been a really rich wetland hunting area. You can see here, so this is kind of that Haudenosaunee area, that's Buffalo right there, so right up there. And now that area has been made very small. It was the Buffalo Creek Reservation, and Silo City is a privately owned property. So after the Welland Shipping Canal and the St. Lawrence Seaway, so this is the St. Lawrence Seaway at the bottom and the Welland Shipping Canal at the top, grain stopped coming through Buffalo in that way because those shipping channels were much quicker and much easier. So there were these monoliths left behind. So this is kind of a picture of inside, so kind of some of that industrial past left inside of the silos. This one is called Lake and Rail, and you can see there was like a train yard. This one was the last one that was used up until around 15 years ago, but there were train tracks. And what it brought with it were a number of ecological problems on site. So the disturbance caused things like compacted soils. So the soils are really compact. There's a lot of impermeable surface. There's also very high alkaline in our soils due to the rail tracks that were there. There was dumping on site, so it was also used for times as an urban dump, so there's a lot of waste on site. So our soils are now a mixture of very anthropogenic melange, a mix of all sorts of things. In addition to having a highly disturbed soils, we also have kind of the trifecta of Western New York invasive species, plant species, which I'm sure you're familiar with. So we are dealing with mugwort, we're dealing with Phragmites, and of course, Japanese knotweed. So it has kind of become this urban wildland, this post-industrial urban wildland. And we have kind of two elements to it. We have the infrastructure itself of the silos on the river, and then we have kind of this urban wildland there. So in 2006, a man named Rick Smith, who is shown right here, at least his back, was bought the site. He had initially intended to build an ethanol plant when he realized that that did not make sense on site. He actually shifted his vision to having arts and culture as well as heal the land ecologically. And so he invited artists of all sorts to come and engage with this space. So I just wanted to show you some examples of what that is. This is, for instance, a large-scale installation inside one of the silos. There are poetry readings. There is a theater group, a local but renowned theater group who does theater productions. There's art on the silos themselves. So kind of reimagining this space as a cultural hub within Western New York, as well as kind of the arts and cultural, the kind of historical relevance of this. There's also the ecological healing of this space. So we kind of take an approach where we are trying to incorporate design elements, so artistic elements in the healing of this land. And we call it a holistic urban land management. So we come from a holistic viewpoint. How can we manage this land in a way that incorporates people as well as supporting ecosystem services, functions, and species, biodiversity? So some of the things, for instance, that we've done are, these are kind of early erosional bags that we made filled with compost. This is a trellis that's on site, and this trellis was built in collaboration with University at Buffalo School of Architecture and Design. And right now, I have a picture later, I hope, of it. It's completely populated with willows and native vines, but kind of to bring together this kind of arts and ecology view. This is Elevator B. Named after the grain elevators. That's the name that would have held the grain, the silos themselves. But we also are doing kind of large-scale projects on site. This is no longer there, but was a large pollinator garden of all native plants, supporting native pollinators on site as well. So we realized as we started to formalize our work that we were doing on site, because it was a bit, when I showed up, it was a bit of the Wild West. There was a project here, there was an art event there was lots going on. And so to formalize it, we realized that we needed an organization to support these endeavors. And so we formed a nonprofit called the Lyceum at Silo City. So the Lyceum at Silo City, the name was inspired by Aristotle's peripatetic schools from ancient Greece. So that was schools in which Aristotle would kind of walk and talk, problem solve, learning by doing what we now call experiential learning, approach to both philosophical and scientific inquiry. And we were inspired by that, hands in the soil approach. And so we created a nonprofit. We are a 501c3 nonprofit. And as I mentioned, what we do is we kind of look to inspire other post-industrial sites through this holistic urban land management approach. And we try to use this land management approach and Silo City as a site itself to say what's kind of best case scenario in urban environments in terms of supporting an ecological healing, so ecological restoration, as well as incorporating people into the mix. So our mission is to advance these techniques. So we do a lot of experimentation on site, and we like to share that experimentation. And as you can see here, I tried to highlight, we basically do that through environmental restoration. That's kind of our ecological focus. Site responsive arts. So that's, for instance, the trellis, and I'll show you some other examples, but that's our art. And then community engagement, and that's culture in a number of ways, honoring the indigenous history of the land, as well as historically the post-industrial usage of the site as well. So how does that actually happen? What does that really look like? So this is, I'm just going to do a few examples. There are a ton, but just for time, I want to be mindful. So we wrote a grant through the EPA and with a local organization called People United for Sustainable Housing, PUSH, to do a workforce training project where we brought folks from the west side of Buffalo, which is historically newly landed Buffalonians, down to train in ecological restoration. When I pointed out at the beginning that there were some areas that were not armored along, we used this as a demonstration site. So this here was us. We regraded, we actually put in erosion controls and did a number of plantings here, as well as using it as a training method, so kind of bringing the people and the place elements together. It also looks like, I won't go through all of it, but we do monitoring projects with high school students. We've had groups come out doing yoga. This was a public training where we did a floating wetland project. We have a water on site. We've done composting workshops and trainings, and we also do support social justice trainings as well. So I just want to reiterate again, if you take nothing else from this, that we are basically trying to bring together people in place and heal the land as an inspiration on an urban scale. This is another example. So this is kind of the first iteration last year, and then this is a picture of it grown out after just 1 year. So this was an art piece by an artist named Dara Friedman. Dara is I believe she's from Germany, but she's based in Miami now, and she came through University at Buffalo to us, and in collaboration with Josh Smith, who's my coworker who's sitting here, the two of them kind of came to this project where they put in a labyrinth on site, a labyrinth different from a maze, not meant to confuse, but actually like a winding path for meditation. And so this labyrinth was put on site, but in an exciting turn, all of these plants here were grown out are all native plants. So these are all native plants that are supporting pollinators on site. I mentioned that we have a lot of plants on site that are non-native invasive species. What we do is we take an approach in which we're not trying to flatten everything and start over. This is already disturbed habitat. What we do, as I said, is try to have best case scenario for where we're working and do kind of what I call like pocket projects to improve the landscape that way. In order to make this possible, we had to have access to native plants. And so we have a native plant nursery on site at Silo City where we grow out native plants for our own projects, as well as in partnership with local restoration organizations, people like the Western New York Land Conservancy, people like the Buffalo Niagara Waterkeeper, so other local organizations who are carrying these out, we are growing out plants for them. I mentioned and pointed out Tift Nature Preserve as being important to us. One of the reasons it is important to us is because we supply the plants that they put in. So it kind of keeps our ecological footprint small in having locally available plants. So we have, this is the inside of one of the hoop houses, or one of the structures, which is a hoop house. So we actually germinate in trays here, grow out native plants. We've decided to focus on mostly wetland plants and woody plants because that makes sense for the Buffalo area being surrounded by water and the types of projects that are ongoing there. And I want to highlight here that these, this is a very low-tech kind of operation. So we are hand watering all of this. This is actually me hand watering some of our things here, but we are hand watering and we're taking care, we're reusing materials that we have to make this kind of a simple and streamlined operation, and it's incredibly successful. One of the other things that we focus on are local ecotype plants. So we are specifically looking at supporting local biodiversity at a genetic level. Yes, there's some people here who are in these photos. So we're really lucky to have both John and Priscilla Titus as a part of our squad because the two of them help to source the local ecotype seed that we can then grow out. What our goal is that we want to get up a native germplasm. We want to get enough local seed so that we can actually have biodiversity supported and then pass that out to restoration projects in Buffalo. So we're looking to support kind of our mission of land management through the growth and sale of these plants. So in last year, actually, we wrote a grant. Thank you. Last year, we wrote a grant, and we through the Buffalo Niagara Greenway Commission. And we were awarded money to expand our greenhouse. So basically, one of the problems that we had in Buffalo is actually accessing native plants. So people would always say, oh yeah, we need native plants for our restoration project, but we're getting them from the Midwest. And that didn't make a lot of sense to us because if we have the ability to grow them here, we want to do that, especially if we're able to support that local ecotype, those local genetics. So Josh, who is here, along with our coworker Patrick, built out a second part to the nursery. So we have the hoop house, and next to it is the nursery. Now I have to say, you'll notice that we have a wetland area here. I'm going to tell you what we're growing in there, but we have a wetland area for our wetland species. And then on the other side, we have our woody plants. We're actually growing out thousands of woody plants and hundreds of wetland plants as well. And we sell these as well as use them as an educational tool, which I'll talk about in a second as well, always ahead of myself, but we use as an educational tool. You'll notice that this is on a concrete slab. So I wanted to point out that this is, so Silo City's over here, this is a building in business called Rigidized Metals, and Rigidized Metals is owned by Rick Smith, the person who also owns Silo City, and this is actually in his parking lot. So this whole structure, this whole expansion structure used to be on an old tank farm. So we're repurposing these urban areas to grow native plants where previously they would have been a space that held industrial chemicals. So we like the idea of kind of taking what infrastructure is there, using it in the ways that we can to better our region. So we also, as I mentioned, are growing partnerships. So we're growing out these plants for restoration, and part of what we wanted to do was not just be somebody who's selling this for money. We are a nonprofit, we're mission driven, but we wanted to make sure that this was available to other people. So we have been partnering. These are rock socks, which I'm going to talk about in just 30 seconds, but a restoration strategy that Waterkeeper has just started and couldn't access. They were actually putting these rock socks on trucks and bringing them from the Midwest, which makes absolutely no sense. To us, what we realized is when we're able to keep these plants local, when we're able to keep this plant material local, we are lessening the amount of gas that it takes to get them there. One of the other benefits we have is that we can hold on to things for longer. So if any of you are in the restoration field, you know that sometimes timelines can get shifted by, for instance, volunteer availability, by weather, and all sorts of stuff. And so what this does is kind of gives the benefit from these local partnerships that we can hold on to them for longer for them as well. So one of the things that we're doing are growing out these rock socks. This is basically a strategy. Who here has seen or heard of a rock sock? Okay, so so very few. Okay, so the cool thing here is it basically is like a burlap sack that has a heavy substrate in it that has pea gravel. Oh my God. Okay, so anyways, it's really cool. It's a rock sock. They're for shoreline restoration. I do want to touch on this final thing, which is that we also realized there was a lack of environmental literacy in Buffalo, and so we have outreach with a local high school program, so career and technical education. So these are horticulture and conservation students, and we have them down to do hands-on experiential work down at Silo City, because we realize that we have to pass the baton to the next people. And so so we have them down partnering with U.S. Fish and Wildlife and showing them, for instance, aquaponics system. We did some native plantings with Tift, our neighbor. We did some native plantings, and then some riparian studies. We did some fish studies. So in summary, what I hope you take from today is just that we are at an urban scale trying to inspire what is possible for land management, which includes restoration, always including people, and passing the baton to the next generation. Do you have any questions? I'm like, oh my God, you guys, I'm so sorry. I did run this through, but I did it at home. You know, it's more relaxed there. Please.
So it looks like you are right there on the river, on the water. Do you guys do any water testing or sampling?
So really interesting. So we have in the past partnered with another local organization who has done kind of water quality testing there. And we've done it with students in order to show kind of the different water tests as an educational outreach tool, but we ourselves are not doing anything kind of for standard water quality testing. But I'm pretty sure, and Josh can correct me, I'm also going to defer because he's here, but also like DEC and stuff comes down and does water quality testing on site as well.
Waterkeeper group.
And our waterkeeper
Very
group
good
as well.
testing, so, yeah.
Exactly.
A lot of restoration work has happened in the Buffalo River, but many millions of dollars have been spent on it over the last decade or so. So it's definitely focused, like we almost like year-round for us to be doing, because
They're doing it.
Yeah.
And if you're like on a kayak going down the Buffalo River, you actually see like restoration spot after restoration spot. It was originally an area of concern, and I don't believe is listed as one any longer, which is great.
So if anybody else has another question, you can definitely see RSC.
Yes.
Okay. So our next talk is wetland. Oh,
JK, sorry.
our next talk is wetland restoration at Presque State Park, a never-ending story, and our presenter is Holly Best.
I assume it's on here somewhere.
It should be. Oh, yeah.
Where's my?
Eric's here, so.
Oh, the last slide.
I don't know where the mouse is.
I don't either. Where did our mouse go? Oh, here it
There
is.
it is. It was
Disappeared.
sleeping. Yep, second one. Yep. Good to go.
Oops. I pressed the wrong thing. Okay, yeah, we went to the slide button. Where'd that slide button
Down
go?
below there. Over. There you go.
That one.
Yep, perfect.
Yay!
We did it. It takes a team. It takes a village. Well, I do believe everyone in here, besides the two of you, have seen something about this presentation before, so spoiler alert, sorry, guys. This is a presentation we do just about every year, kind of giving an update and an overview of what we're doing with resource management and our wetland restoration project here at the park. This is an image of Gull Point. For those who may not be familiar, this is the distal tip of Presque. It looks a little bit different now. It's a lot more sand, less water, but this was at a high water level year. So a little bit about why Presque State Park is important. So we are the only beach in Pennsylvania. We're on a recurving sand spit that juts out into the lake. We like to say that it is the most engineered natural place you'll ever be. It's engineered to stay put, otherwise it would have slinkied down the shoreline and already disappeared. As it hit deeper water and nothing to catch on it, it would have just sunken down into the water. So we've maintained it here. So it's a geologic feature that is no longer allowed to do its thing, but that's okay, we keep it here. We have all the successional stages from New Beach all the way up to Climax Forest and everything in between, so we're always managing and maintaining all those different habitats. We are located, for obvious reasons, along many, many migration paths. We are home to over 300 nesting, resting birds, 300 different species, many different bats, a lot of different insects. We're on major flyways because when things come across the lake, we're the stop, and before they head out, we're the stop. So a lot of them kind of springboard off of the park. We are also home to multiple species of special concern, including too many plants, animals, fish, turtles to list. We are also identified as an important bird area for a lot of those different reasons. We are a national natural landmark. And then the other crazy thing is we see between 4 and 5 million visitors a year. So we're managing the resource as well as all the visitors. So I know a lot of times people want us to, the people I talk to want us to do resource management, and then we have to remember that we're also managing for a visiting public because we're a state park. So we do have to be all things to all people, which we all know is extremely challenging. But we do the best we can with balancing everything. So here are just some of the special species we have. We do have nesting bald eagle. We have nesting osprey, which that was a new development. The park established hacking towers in like the 1980s, and osprey never used them. They would be here fishing, but they were not nesting. So that is a relatively recent thing within the last 4 or 5 years. We now have at least 3 seasonally active nests. So that's a big success story. We're home to a lot of different plants, hairy puccoon or hoary puccoon, however you want to choose to say it, lupine. We also see some other critters. So we see a whole bunch of least bittern, which is a good thing. We used to not see as many. We are not sure if it's because we're looking for them, we're finding them more often, or if there's more out there because we made a better habitat. We would like to say we made a better habitat, but we know that scientifically we can't really measure that accurately. We do also have a lot of big success stories. We are also the only location along Lake Erie that is now being used by Great Lakes piping plover. So they have nested here. They were gone for 50 to 60 years. They've come back. That is a little blurry image just because we can never get very close to them, but those are some of our piping plover that are found on the park. They've been here for many years now, successfully fledging young from the point. They're always located at Gull Point, which is a good thing too. It's a little bit more protected, a little bit more secluded from 4 million people. So they picked a good location. We also are the only location in Pennsylvania that has Blandings turtles. So we were to the point, actually, Fish and Boat Commission was monitoring the Blandings turtles. We weren't even sure that we had enough to even be consider them a population because we could only find a couple every year, and then Mark was involved with us a little bit with Fish and Boat. They never seemed to be able to find where they were possibly mating or possibly overwintering because radio things would always fall off. All the trackers would always fall off, so we never had a complete story on them. So Pennsylvania Fish and Boat has actually reintroduced several different individuals, so we're hoping to build out that population and be a good location for them. That goes hand in hand with the resource management area because one of our large treatment areas is the location where they're found. So we're pretty confident that we're making that much more passable now that it's more open water rather than just being full of stands of Phragmites and cattail. So just to give you an overview of the history of control from like the late 80s through the 90s, we kind of didn't realize what was happening, I think, and I think a lot of places didn't, and invasives just kind of took over. And we all just kind of woke up one day and went, we used to be able to see water here, and now we can't see water anymore. And what is that plant? And then I think it kind of came to a head when one of the biggest questions we would get once we moved up to this building, and even before that when we were down on the park in the Stall Center, people would say, oh, there's this beautiful plant with this big plume on top. Can I get some to take home? I've never seen, it's so gorgeous. And we're like, wait, no, that's bad. And that's what people are seeing. We have to do something about this because we don't want them to see that. Like, we have all these other good things that are being masked by this terrible plant. So In the 90s, we began working with invasive species control. At that time, it mostly was one of our nonprofits, the Presque Partnership, funding a couple interns, throwing a couple dollars their way to cover their travel costs, and they were clipping things in the median, which we all know didn't really do much of anything. So through the 2000s to 2007, we did build up a bigger crew, but we were still just using manual means and just hand cutting mostly with interns. We were not using any herbicides or anything yet up until that point. Then the Great Lakes Restoration Initiative funding started. And we are in a unique position here that we have a foothold on the lake. So we are the game in Pennsylvania to be able to get this funding. So we started applying. We have been getting funding successfully from them competitively since the first year, which was 2009. So that was the first time we introduced herbicide into the landscape, just knowing that we had to do that in some of the areas that were just so inundated and where there were just drastic, severe monocultures. And then also in the next grant, we're like, hey, that worked. Let's try something crazier. So we rode in a helicopter. So I talked to some folks at Cleveland Metro Parks, and they said, well, we've successfully used helicopters in some of our natural areas. And I'm like, I would never think that. So we thought, well, let's see what happens and see how many complaints we get. So in 2012, we used a helicopter to spray 100 acres, and no one said anything. We just closed the back half of the park for like half a day, and they went into all the areas that we can't get to otherwise. So I thought, well, let's just keep writing that into the grant. So every probably 4 to 6 years, we'll probably do a helicopter spray. So that's kind of how it's working out in our timeline. So 2012 and through 2018 was really building up all of our stuff. So that's when we bought a ton of equipment. We got several different tank sprayers. We have a 25-gallon, a 50-gallon, a 100-gallon tank sprayer. We have backpack sprayers for all of our interns. We've had up to 16 interns in a summer, as low as 5 interns in a summer. We purchased an airboat, which was a total game changer to get into some of our wetland areas and especially the lagoon system. And we bought all the different attachments for everything. So this has enabled us to really really put our boots on the ground, get in the water, and do as much as we can, pushing at all of these targets. 2019, again, we brought in the helicopter. They sprayed about 150 acres that time, and their targets when they're spraying with the helicopter are Phragmites and narrow-leaved cattail, and they can see it right from the sky. So if we were more better equipped with GPS and GIS systems, we could give them shapefiles, and they'd be able to but the pilots have been phenomenal. They can see it. You can see it from an image once you're calibrated to it. So they're really, really good at just hitting targets. So then from 2019 to the current, now we're just following up. We're following up with all those treatments. We're still pushing on those leading edge of those largest infested areas, peeling back those layers. We are also working with the Regional Science Consortium, which I'll get into a little bit, and Jen will talk about as well, reintroducing propagated natives that are propagated right here from the park, on the park, put them right back. We're finding new invasive individuals, which is happening. We're at water level. So when water levels change, different things get wet, different things get dry, and we're like, oh, that plant was never there before. So we try to get those individual plants before they turn into something larger. And then our last helicopter spraying with the current grant we're in just happened in 2022, and that included 100 acres. So some of those helicopters, that's the only way we're able to get to those areas. So many of those acres are retreated by the helicopter every time, but some of them are new infested areas. I'm sure most of you are very familiar with all of our invasive species. This is just a handful of the most common ones that we find, but we have them all. We have them all. Jen just told me about another one we have. Thanks, Titus's. Now you're here and you're finding stuff. So now we know that we have all the things. But we do work a little bit on the terrestrial side of things, mostly with Jen, working with some volunteer weed warriors, which we have one in the crowd here, so thank you. So those folks usually work on upland, doing more manual removal, and then the interns are pretty much working on that emergent edge, doing a lot of the different herbicide treatments, a lot of digging, which Sam was a previous intern as well, so his favorite thing is to dig out purple loosestrife, I think. And then we also work with a crew from the park that includes environmental education staff, maintenance, a couple seasonal rangers. They go out in the fall time on the boat and really just hit those edges they can from the boat. So here we basically have like 4 different tiers of prioritization. So some of those very high value sites, like where we have the lupine growing, where we have the hairy cocoon, where we have prickly pear, those are considered very high-value sites. So we make sure that we maintain those areas as weed-free as much as possible. We're out there a few times a season, making sure that we're pulling up even little natives that are popping out. We want them to have space to grow. So we push the edges back from there, maintain those areas. We're always constantly following up throughout the season on those high-value sites. If we see those small-scale infestations, a frag popping up, a cattail, one purple loosestrife, we make sure we get those next. Those are obviously something that's a little bit more manageable. And then we're pushing on those big, huge walls of plants that we don't want to have there anymore. And that's when we're addressing the fields of purple loosestrife. So those are pretty much our tiers of prioritization. So our best management practice is, like I mentioned in the previous slide, just protecting the best. We have those special habitats. We want to make sure that we're maintaining those. And we're also encouraging native plants to fill back in by removing only the invasives. We are to the point now where, I'll show you in the next slide, we use a variety of different control methods. But we also just consider this like peeling back the layers of an onion. So we get the next layer, get the next layer. If you were to go on a boat in the lagoon system, you would see, some frag in the front, just kind of dead, kind of sinking down into the water. The one behind it might be standing but be dead. And then right behind it is like the new frag saying, hey, I'm your target next year. So that's kind of what it looks like every year as we push back further into those monocultures. So we use every different treatment method. We're very fortunate to have all the tools and equipment. We say we have a large arsenal. We have a large arsenal ready to attack at any moment, but we go from a very meticulous type of approach, using something like glove of death, which is literally a latex glove covered with a cotton glove with herbicide directly on it, just going after an individual plant stock, all the way up to a helicopter and everything in between. So you can see we have a pontoon boat that we use. This is our pontoon boat that we used to use all the time before we got the airboat, which really gets us into a lot of different places. This is some interns, this is Horseshoe Pond, out in the water spraying back toward this huge pile of frag. And then, of course, interns, they actually go from this tank sprayer. When we're using the pontoon boat, they use this tank sprayer, which is a 100-gallon tank sprayer. They drag about 100 feet of hose out into the wetland. They spray above their head, work out, spray above their head, work out, in kind of a big pattern. So it's a lot of work walking in really unforgiving wetland areas, hauling a very heavy hose that's full of herbicide. But they do it, and they get paid, and they love it for some reason. I don't know, unless they're lying about it. But they really do love it. So, so how we manage and how we identify, how we kind of quantify what we've done. So we identify area treated and area protected. So area treated is specifically where plants have been dug up, cut down, or sprayed with herbicide. Area protected is the entire area that's been worked on. So that's all the boots on the ground, in a boat, everything. So when we first started, we were just about matching our numbers. We were treating everything, we were protecting. Everywhere we walked, we had to do some sort of a treatment measure. Now we have turned around since 2009, 2010, and now the area we treat is about 25% of the area that is protected. So that is a much larger number at this point. This is just to kind of show you our area protected. We're real close to about 500 acres. And this does not include Area Bluffs, which is one of our satellite parks that we also go and work on. So this is one of our big, I use this picture in every presentation because it's awesome. So winning. So this is Surprise Pond. We found a pond. We didn't know it was there. It used to look like that. And now it is home to many, many plants that are popping up that we didn't even know were still here. So it's kind of been fantastic. People used to say when I first started this, because I have learned as I went, I'm a park manager, I am not a botanist, I'm not a restoration ecologist by any means. So people would tell me, well, yeah, you get rid of the invasives and the natives just pop right out of the seed bank. They're there for 50 years. And I'm like, okay, I don't believe you, but this is a success. This is where I can actually go, oh wait, no, it actually does work. This is just another image of that it's working. This is Leo's Landing. When I was here a long, long time ago and in a different position, and this used to be open water, such as we see it now, so we have returned it back to the open water area. Just a lot of different successes, as I mentioned. We have bald eagle nests, we have osprey nests, and one of a very cool thing, we started seeing sign that we thought we had river otter in about 2018. Volunteers were seeing it, some of our staff were seeing it, but there's no proof unless you have an image. So if you can tell, that little dot is an otter eye, and we caught him on a trail camera New Year's Eve of 2022. There's another image that we actually have 3 individuals in one picture, so we know that there's at least one family unit hanging out. So we can't do anything that we do here without Great Lakes Restoration Initiative. We do not fund this with park funding, it's all through grant funding. And we can't do it without all of our nonprofit partners. So this is a listing of all of them, everybody who's involved. The monitoring end of things is so important to prove our successes and prove that what we're doing is not causing harm, it's actually causing benefit. So we are very fortunate to be involved with everybody. And I don't know if anyone has any interns, but we are always looking for interns. They are funded through the grant, and anybody can apply by January 31st. Send your info. And that's all I have.
Questions?
Do you direct the questions that, of what is being monitored? Like, do you say, hey, we want to know this, whether spraying or spraying and planting is more effective? Like, do you give the questions, or are the people who are monitoring asking their own questions?
So they're asking their own questions. So, and mostly it is a standard monitoring protocol. So they started before we started doing the work with the herbicide, and they're continuing. So they're able to present, you'll hear I think he's gonna present on it, like frog calling. So when they used to check in this area, they'd only see X, Y, Z, and now they're seeing X, Y, Z, all the things. So they're just using their standard protocols in our treatment areas.
Are there questions that you want answered that aren't being answered? I'm just curious.
Yeah, I don't think so at this point. We do have a really good working relationship, so, and it's probably mostly with Jen and I with the plants, with us.
You too.
Us two, because it's more specific to like what plants are gonna succeed in an area, or where do we need a little bit of a jump start in an area where we might have just removed a lot of things. So we have a very open line of communication between myself and the partners who are doing the monitoring, so. But they're really good at doing what they do, so they know what they're doing. Okay.
Questions?
I'm wondering about some of the challenges you have just in the park bureaucratic
Yeah.
system.
That exists. So I took that slide out, but I talked about that at the NOMS conference. So we have a lot of different challenges. So we can't accept grant funding because the state can't figure out how to do that. So luckily, we've figured out all the loopholes and working with nonprofit partners. The Regional Science Consortium has been awesome. Prior to that, we worked with Ducks Unlimited. Prior to that, we worked with another nonprofit. We've worked with the Presque partnership. So we will partner with whoever can help us get the work done. So that's one thing has been challenging. The other thing is staffing. So state parks, the whole department is held to a staffing complement. So we can only have X number of people in the whole entire state park system. And then each park is maxed at a staffing complement, which we are at. So I can't add any positions. So even though I know that adding maintenance positions, working in the shoulder seasons and the summer would be fantastic, we can't do it. So that's why we're very reliant on interns, which is not the best setup, but it's the best we can do. Ideally, we would not want to be doing all this work in the summertime, but it's the best we can do. We push back as far as we can, not starting most of our treatments in our wetland areas. We don't start them until after June 1st. It's what we can do. So you just kind of zig and zag and find the balances and kind of work around the
Do
bureaucracy.
you feel supported in the park system to address this, or is it more like, why are you doing that?
I mean, I think people value it. I just think they don't fully understand it because once again, we're the only park that has access to this funding. So the majority of other parks do not even work within the realm of grants. It's foreign. It's a foreign concept to them. I was very fortunate when I started at this park working with my previous manager, Harry Leslie. He was very much thinking outside the box and figuring out how things worked. So he was here on the ground when the 2009 grant, he led the charge on that. So that really laid the groundwork for us moving forward. So fortunately that happened that way because you really have to have really dedicated people to be involved in things like this. Yeah.
Thank you.
Yep. It's Jen, right?
Yep. Thanks for setting that up. Okay, thank you. And our next speaker is Jen Salem, and she will speak on wetland restoration and propagation updates. Yay! And it's already up.
Thank you, John. Let's see here. There it is. So, for those of you that don't know me, my name is Jen Salem. I'm the greenhouse and plant lab manager for the Regional Science Consortium. I also manage a program called Weed Warriors of Presque, which I will touch on in my presentation. And I also am the director and founder of a group called Go Native Erie, which is an organization that promotes the use of native plant species. And today I'm going to talk about our wetland restoration, particularly the propagation part of it. So I kind of feel like overview, there's a lot of partners involved with this restoration project, and every partner has their own individual kind of piece of the pie. They all do different things. Our work complements each other, but we definitely are I'm very specific to plants. So don't ask me about birds or water quality. So, but anyway, like Holly mentioned, I like to use this picture too. This is what a lot of areas on our park look like. I'm gonna flip back to, this is Leo's Landing, just a few years ago. And what you would have seen when you drove out there was more like this. And then the park started to treat the invasive species. Move on to my next slide. I wasn't like brought in until about 2016, which I think is the first session that we had funding to do propagation. And a lot of our issues were that there were big areas of biomass. There wasn't really a lot of things coming up in that area. And I feel like we needed to kind of kickstart some of the wetlands. And we also, I guess, had the ability to do it. And I'll touch on that and kind of go through some of our unique facilities on Presque Isle, because this isn't just like you folks from Silo City. You realize like you have to have the infrastructure to do, like to grow the plants and to do the restoration work. We do have a unique program. We are the only in-house propagation program on any state park in Pennsylvania, which makes us very unique. My hope is to one day start others at other state parks. It's definitely doable. You just need like a good working relationship like Holly and I have. You have to, because we're not a state agency, we work on state property. So there's a lot of hurdles that she can kind of help us with. So anyway, all of our plants are propagated like from plant material in the park. So we have for the park, on the park philosophy, which is very similar to what you're using. Like, I feel like we're very in tune with your program, even though I didn't even know yours existed until the Tituses started to work with us. And I think that's really cool that like mines, right? You're thinking, why not use the plant material that's here? We have that specific genotype. We're kind of a closed circle where we're collecting seeds, we're growing seeds, we're taking cuttings, and then putting those things right back in the areas that they were collected from, which is really cool to do. And then every year, like I said, we grow for the priority wetland sites, and I'll talk about those locations too. So we have a lot of different propagation methods that are used. Some work better than others. This is my hand. We're obviously seeding. We take some vegetative cuttings, but that the time that we do that is like conflicts with a lot of when we have interns and volunteers coming in. So I don't get to do as much of that as I like. We do about, a little over 5,000 hardwood cuttings, which they come in like that. When they're grown out, they look like this. We also do some like direct sow and hardwood or live staking. We're kind of playing around with different methods to see what we can do to increase our production, but not take up any more space because we kind of have outgrown our site right now. So this is our growing facility where we store all our plant material for the restoration work. We also grow for individual projects like educational projects, and then we have some Western Pennsylvania Conservancy plants on site, and then we also have a native plant sale, which is a virtual online sale, but then you come in and pick up your plants at this building. And this, just to give you an idea, this is, oops, no. Oh, wow. All right, got a little ahead of myself. These are all hardwood cuttings that are being grown out for the restoration work. So that's just one section. We also have a lot of vegetative, herbaceous things. And then we also have like a cold frame greenhouse, a storage shed, and a deer enclosure, which is right here. Because we do have, obviously, issues with browse because we're right in the middle of a state park. So our next facility feature that we have is the Regional Science Consortium Greenhouse. That is located in our building in the restricted access wing. And the thing to note here, like some of the hardwood cuttings are being put in here. This is what it looks like in, say, March. Not only are we using the bench tops, but we also are using the floor. So we just don't have adequate space. We are looking to address that. And like y'all know, like there's no free greenhouse space. Like everybody that has it is using it or renting it. So we do the best we can in that. We also have, oh, I think somebody's in the audience is in this picture. We have the plant lab, which is my office. It's also a place where we do, we bring in plants that we've collected. We do identifications here. We do a lot of work. We have volunteer groups that come in and help us. And it's nice to have a place that houses all of our soil pots. We have a plant library that is located there. And then we also have something that's kind of new. As of last year, we have a seed bank. This is a way to store seeds. We have a walk-in cooler. Our seeds are collected, they're processed, and then they're stored in this. And we've really focused this year on trying to increase the amount of seeds that we have. So you can't really see it on the label, but what is on there is the common scientific name of the plant, and then the location it was collected from, and the year that it was collected. So we're working very hard to get that kind of up and running, because prior to having this, we stored everything in a storage tote. So this has really been an upgrade for us, but it's also something that has like kind of fueled a passion in me. Like I'm trying to collect everything I can, and the Tituses have been helping me fill it up too, so, which is really cool. Now we just have to print out labels and do the database. So, but the highlights this year from just that seed collection, which I feel again is very important. We're able to house over 100 species right now and counting. We're still bringing seeds in. So, and then that won't stop until I can't access any more seeds and there's too much snow. And then we did add 28 new species to our list. I'm starting to really get into the rushes. So not great at identifying them. That's why we have the Tituses helping with it. But it's really cool to just be able to find things that you've never seen before. And I feel like every day that I do field work on the park, it's like there's a new discovery. There's always something new to find or see or learn. It's wonderful. And so I did take some pictures. These are action shots of my hand grabbing the plants that I'm going to harvest, but it's also just to show the cool diversity of the seeds and how interesting they look. So, And then we do have 6 sites on the park that we plant. We have the entrance, wetlands, Leo's, Thompson's Circle and Thompson's Bay also incorporates Surprise Pond. That's the area that Holly was talking about. And then we have Misery Bay, Niagara, and Horseshoe, and those are 3 newer additions to our restoration zones. And I'll kind of go through, these are some pictures of them. The picture with the houseboats, that's Horseshoe Pond, that's a really interesting place. Misery Bay, the picture that has all the pots lined up, ready to go out, that's a place where a lot of ice fishermen go in the winter. So we're putting those, we're walking those down along the shoreline and putting those in. And let's see here, okay. This is just on a map. If you're not familiar with the park, I'll just kind of briefly go over the entrance wetlands are literally right when you get onto the park. Leo's Landing is a little peninsula that sticks off of the peninsula, and that goes out into Presque Bay. That also has an observation tower that is worth checking out because you can see over the wetland. We have Misery Bay, which is here, and Niagara Pond, which is here. It almost looks like one site, but they're literally right across the road from each other. There's Horseshoe with the houseboats here, and then this bigger area is Surprise Pond and Thompson Bay, the shoreline of Thompson Bay. So we added 2 new things to our program this year. They were very small additions, but I just felt like they were notable. Just to show you that we're always branching out and trying to revise some of our methods. We had an intern take on a live stake project. You can see the species lists that she put in. And she put those at our entrance wetlands. She would go out once a week and monitor growth on those. And it's kind of a still ongoing project, and it was more to see what, if anything, what does better where. We went from our multi-purpose trail, which is a more upland site, went all the way to the water's edge with the stakes, and you can see a flag here kind of indicating where the stopping point is. And I know that a lot of her things had pretty significant growth, so I think it kind of just is showing us like, okay, we can use live stakes. Unfortunately, we cut those in the winter, put them in buckets and put them in our cooler and did not take them out again until June, so they actually lived kind of. We sort of abused our live stakes, but they're all right. And then we had a very generous donation of rock socks, which I thought were the coolest things. And I kind of like thought for a while, where do I want to put these? And an opportunity arose. We have 2 ponds that are called Waterworks ponds on the park. And there were some dead trees along the shoreline of one of the ponds, and our maintenance department pulled them out. And while they did that, they sort of destabilized some of the shoreline, and they put, you can see kind of riprap, like this rocky stuff here. So I decided to drop the rock socks in near those locations, because a lot of vegetation was removed. And I thought that would be a great test plot for those because they are really accessible, and that area, there's an area where new trees are being planted, and that's kind of undergoing some, well, not necessarily restoration, but maybe renovation, in that like a lot of dead trees were taken down. And so I'm curious to see what these do, and I think it's really cool. I'll come back next year and check on them and see what's happening. And yeah, so again, we appreciate that very much. And then I did want to briefly touch on our Weed Warrior program. Our Weed Warriors complement Holly's invasive species team. So Holly's team goes in, they do some manual removal, but for the most part, they're chemical applicators. Our Weed Warrior group is a group that manually removes plants. We kind of survey areas, we scout for invasives. In the past, it was a little limited because they were only focusing on 2 species of plants. We unfortunately keep adding more and more plants to our target list, and that's only because there are new pockets of invasives constantly coming in. And so we just unfortunately are going to have to keep adding to our list. We definitely have a need for more volunteers, more people that are dedicated and will help remove the invasives on the park. And we meet once a week. We also incorporate students occasionally. And you can see some of the invasives that we're pulling out there. There's piles of them. We have an issue with what to do with our biomass. And so that's something that we're kind of working to address because we make a lot of it. And when I say a lot, like there have been times when we've taken truckloads of things out and we have to throw stuff into a dumpster, which isn't the best way to, I think, manage that. So Weed Warrior events, like I said, are weekly. We also incorporate student groups that come in, and their hours are counted towards our Weed Warrior program because they're also doing invasive removals. So that's just an example of that. Weed Warriors, this map is from last year. We don't have all of our data in because we're still meeting as a group right now because the weather's holding out. We've covered over 180 acres this year. We've had more than 30 volunteer events, and we also have over 500 hours logged for that program, which is pretty cool. Again, more pictures of some of the work that we do with interns. We work with botanists, run transects, do all kinds of fun stuff. We also work with Pennsylvania DCNR on some of our programming, and then that's kind of all I have. I would like to particularly just give a shout out to our collaborating botanists. It's a pleasure to work with people that not only are generous with their time, but also with their knowledge. So thank the two of you very much. And any questions?
What do you see for next year?
What do I see for next year? I think that I would like to increase seed collection, and that's something I wanted to start earlier because I feel like that June, July, August I miss. I may want to incorporate new planting sites because I feel like there's other areas that we just have not touched yet. And a lot of our initial sites were chosen because of the easy access, like easy to bring truckloads of plants, shovels, groups of students. Anything that, needs to be transported on a truck or a bus, is kind of how we pick the sites. I'd love to get into the lagoons and do some work in there. But yeah, there are always ways to expand. And then if we do have more greenhouse space, which, like I said, we're addressing right now, that will open up a lot more growing opportunities for us. So, yeah. Yes.
Of the seeds that you stored, you're not growing out all of them. Yeah. So do you just basically, you're collecting the seed and then you look at your kind of project objective and then pull from your seed bank to grow those?
Yeah, so it's that was my question at first. Like, are we keeping these forever, or is this a working seed bank? And it's a little bit of both. And it kind of prior to getting that, we really did just collect what we could use for the next year and did not save anything. And there was a particular example from this year where I believe something that was unusual and rare to begin with has now been extirpated from the park. And if I would have collected seeds 5 years ago, it wouldn't have been because we could have grown them. So just kind of lesson learned there. Yeah. So, all right. Well, thank you.
So I don't think that Dr. White is here, so that actually ends this session early. So thank you to everybody who came. Those were 3 great talks. And in not too long of a time, there will be lunch over there.
Right now.
Oh, right now.
Everybody is invited to go to the cafe and you can get some lunch.
Okay, thank you.
Yo.
Bye.
Yeah. Yeah.
We have like a minute left, but before we started, I wanted to announce, if you didn't hear, there's going to be a tour of the Trek Natural History Museum at 6 in the basement, given by Mark Letheby. And if you're interested, you can sign up at his table right outside of here. So with that being said, I will introduce our first speaker of the session, which is Sarah Maggian, and she's going to be presenting on biological surveys in restored primary wetland habitats on Presque State Park, Erie, PA. So it's in presenter view now, so you can actually see it.
Oh, thank
And
you.
here's something we-
Appreciate that.
You're welcome.
All right. So yes, biological surveys in our restored priority wetlands. So this was already gone over in the last session a lot, but I'm just going to do a brief overview. We have been working to restore and protect native biodiversity in the Presque Isle wetland habitats. This has been happening through the chemical and mechanical removal of invasive plant species, the propagation of native plants and implementing those into the wetlands, and then the part that Sean and I are involved in, which is the monitoring of the biological indicators of this wetland health, which is amphibians, fish, macroinvertebrates, and mussels. So amphibians and fish were added to the project in 2017, but macroinvertebrates and mussels were added in 2020. So first we'll go over the amphibian monitoring, and I will say that this is Sean's area of the biological monitoring. He's right there, but I am presenting on it today because he's presenting on something else. But so if you have questions on it, you can find Sean afterwards. So our sample sites for the amphibian monitoring are a little bit different than they are for the other monitoring, but this one has 7 sites. So the entrance wetlands, so right as you're going out in the park, directly to the right there, Leo's Landing, which is where the feather is, if you guys are familiar with the feather on the park, both sides of Marina Lake, Ridge Trail, which is kind of like behind the maintenance area of the park, Thompson Bay, and the Coast Guard wetlands, which are out near the Coast Guard station. So we record using wildlife acoustics psalm meters, and these are to record just the audio to help determine what species of frogs are present. So we deploy these every week, and it has varied over the years if we do that at 1 site, 2 sites. This year we were doing it at 3 sites, but we try to get as many of them as we can, and we just have a rotation going. So every week we're recording these sites for 3 nights. And then they produce on their software, which is free. You can buy a premium, but we use the free. But you can look at and visualize those sound files. So you can actually use this to determine the species of the amphibians that are present. So for example, in the upper left there is the American bullfrog signature. And then the gray tree frog is next to that. And below is an overlay of the gray tree frog and the spring peeper. So you have to actually, you can see both of them in there at once. If you can't, if it's like just a big blob of noise, you can always just listen to the recording and hear it that way. But this actually makes it much easier for us to process because we record for 4 hours every night that we deploy these. And we do not have 4 hours to listen to the whole recording. So it's nice that you can go through and get the visuals and know these species are present or absent and move through it quickly that way. We don't try to account for the number of any species present. It's just if the species is present or not. We can't determine the number of individuals with this. So these are some of our common species of amphibians. I'm sure many of them look very familiar. The cool thing with this, though, is to look at their signature that's right next to them. So the Fowler's toad and the American toad look very similar visually, but their signatures are very different. So it's easy to tell those species apart when you're listening to them or viewing the sound files. So one of the species that we keep an eye out for here is the northern leopard frog, because it is, I don't know what the exact term was for it, if it's critically endangered or a species of concern. Ask Sean afterwards. But it is one that we are concerned about in this area, and we have actually found recordings of them now at 4 different sites, which is really cool, because whenever we first started this, I don't think they were anywhere. All right, now this is actually my project, fish monitoring. So we do 5 different sampling sites for our fish surveys. A lot of these overlap with the amphibian ones. We just don't do all the same locations. So you can see I have 5 of those. So once again, the entrance wetlands, Leos, both sides of the marina, and then Thompson Bay. So for our fish monitoring, we have a couple different sampling methods that we use. We consistently have used our seine every year. The seine is the one in the very top picture there. We do 2 to 10 polls per sampling site. And we sample each site in a month. That's the minimum, is we have to get to every site once a month with the seine. We have also used a pike net, but we do not use that every year. And it was more advantageous when we had really high water levels and there was a lot of debris in the water where we actually couldn't pull the seine because there was a bunch of tree branches and stuff like that. So we could deploy the pike net in those times and get the samples that way. The pike net you can see in that image on the left. And then all we do is I catch all the fish, we identify them, but we return them. We don't keep any of the species. We just identify their species, count how many we have of each, and then we return them. So that's a picture of me as an intern, hands in the bucket, grabbing fish. We call that fish wrangling. It's very official. So here's some of our common fish species. I'm sure many of these are very familiar. The spotted gar, we actually found these in Leos with our pike net. They were all spawning in there, so we caught the whole group of them at once, which was really cool. And I was informed by someone that one of these photos is inaccurate, so I have to change it, but that Johnny Darter apparently is not actually a Johnny Darter, and I will fix that. But some other species that we have. Obviously, the round goby is invasive, but we find a lot of them. We also find the tube-nosed goby. All right. Our macroinvertebrate sampling was added in 2020. This is the same 5 sampling locations that we have for fish. So for our macroinvertebrate sampling, we use D-frame nets to collect our samples, and we drag those along the emergent vegetation in the wetlands. So anything that's partially underwater but also sticking up, we kind of scrape the net up against it, trying to catch these guys. And then we collect everything from within the plastic jar that we have, and we just cover it all with ethanol for later picking it. We can't pick everything in the same day that we collect it, so we just get everything from that sample into a jar for that location, and then the interns go through it later. And then these samples are used in a macroinvertebrate diversity index. And the reason that we want to do this is to look at the wetland health. So some species are more tolerant to pollution than others. So if you have a lot of species that have a very low tolerance to pollution, you have a very healthy system. If you had a lot of species that are super pollution tolerant and you had none that were very low pollution tolerant, that would indicate that you had poor water quality. This one's my favorite. This is our mussel monitoring project. So we're looking at a family of freshwater bivalve mussels that have been decreasing in population since the 80s. In recent years, they were shown to be missing from Presque State Park habitats where they used to be prevalent. And the last study before ours was done in 2013. So we started ours up in 2020 to take a look at them. This decline is likely due to the introduction of invasive species like the round goby, the zebra mussels, and the quagga mussels. So in these pictures, can you guys see my mouse when I do that? I don't think you can. So these are their little tags. We get yellow tags for them, and they have a letter and then 3 numbers, so we can identify all of them, and we just super glue those onto them. This is a mystery snail. We just end up finding a lot of snails while we're down there, so they hang out. We only do this at a few sampling locations. We have tried a lot of different locations, but we have only found live native mussels at one site on the park, and that is at Thompson, up here. That is the only location where we have been able to find native mussels. We found their shells at other locations, but they're not very fresh. They're usually pretty degraded. We just haven't been able to find live ones anywhere else on the park. So we've tried out all these other sites, And we do try to revisit them every year just to make sure, but we still have yet to find them anywhere else. But we do visit, so once they show up and we have to train them, there's no more time to do a mussel survey. So we try to get it in like that first week of May, which can be too cold. Because we're just, as you'll see, we snorkel in the water, so it has to be warm enough for us to be able to be in there. So we do tactile searching via snorkeling. So basically, we put on a wetsuit if necessary, fins, and then we just go back and forth in our transect. We usually have people start at opposite ends, and we just zigzag back and forth. We have a rope that we hold on to that prevents us from going farther than this distance. And we have 2 pieces of rebar at either end with a rope between them that connects to. So it makes us our nice quadrant. And like I said, 2 people start at opposite ends. You meet in the middle. We do allow for some overlap because some people are just better at finding them than others, especially the ones that are buried in the sediment still. So we do allow some overlap. And then we just collect them all in these mesh bags that we usually wear around our wrist as we're under there. We just fill it with mussels and we'll swap it off to our shore crew, and then we keep searching. So these are some photos of that. This is that rope that's between the 2 pieces of rebar, and then this is the one that we clip to it and we hold on to so we can't go too far out. And mussels are in this bag down here. So we also have a shore team. Their main job is to not only process the mussels, but to just make sure the snorkelers are doing all right. We let our interns try this out every year, and you always hear like a shriek through a snorkel. It's always like, are you okay? And they're like, I saw a big fish. It's usually all it is, but like you still have to be sure that no one's struggling in the water or anything like that. But our shore crew keeps an eye on everyone in the water, and then also they're the ones that we pass the mussels off to while we're still searching, and they begin processing them. So they'll begin getting a part of that shell dried off so that we can put glue on it. We do keep them in water the whole time, and we try to make sure that that water is constantly circulating. We get new water a lot to try to keep the water temperature the same and not stress them out. But we always dry off a part of the shells so that we can stick the tag to them, and then they measure them length, width, and height. So I don't have our 2023 data yet, but this is our data through 2022. Like I said, we only have native species at one of our sampling sites so far. We would really like to have more than one sampling site. So if anyone knows of where any others might be, we'd love to know. But we only have found 3 species at this site, and that is the eastern pond mussel, which makes up the vast majority of the individuals we find. But we've also found the giant floaters and cylindrical paper shell. Giant floaters are really exciting when we find them because they're just so much bigger than the eastern pond mussel. The interns are like, this is huge, and it's a good time. So, first year, we tagged 24. They were only eastern pond mussels, and we sampled for 3 months. Our second year in 2021, we sampled for 3 months again, but we found all 3 different species. One was brought back to us as deceased. Someone found it with our tag on it, was like, I think you'd like to know that this mussel was found deceased on the side, and that was great. I have it still in my office. And then our recaptures, and then in 2022, we had a lot more recaptures, and we were able to do 4 months. We only found 2 species that year, and then this year, I need to actually go through the data, but I think we found all 3 species again, and maybe a 4th, but we need to double check our identification and all that kind of stuff, because since our interns are working with us on this, you know, they're not experts on identifying mussels or anything, but they do try their best to get the correct species. We do use a list of species that were previously present in these areas to help us identify what might be present currently. All right, those are all our project partners, and if you need to contact me, that's my email. And are there any questions?
With the seining data, you said that you do anywhere from 2 to 5?
2 to 10.
2 to 10 passes? How do you guys decide on?
If we're having trouble like if we haven't found or caught anything in the first 5 passes, we usually keep going because we're trying to find, we know there's fish there. It's just that they're outrunning us is usually what it is. So that's really common at the start of the season when we're still training. And we're like, this is how you seine, and you have to like keep your speed up. The intern's like, yeah. And then they can't catch anything because they're just a little too slow with the seine. And then Sean and I will step in and like do a couple transects, get a good amount of fish to, yeah. So that can be some of the variability. Also, if some of the sites, like I said, are a bit overgrown, if there's a lot of stuff tangling you, we do try to reduce the amount just for safety reasons. We don't want anyone tripping and falling. In the entrance wetlands this year, we had almost like a quicksand problem that kept happening where we kept trying to walk in the one place and you would just sink to your knee minimum and then keep going and have to haul people back out. So we were trying to be careful and that would influence how many we got. Any other questions?
Have you run into the tube nose goby anywhere other than Marina Lake?
At Leo's Landing, yes. And that's what our fish viewer is really helpful for, that kind of V-shaped tank, because they sit in there and they'll let the little tubes be really obvious for us. It's very helpful. Any other questions?
How far away do your sites have to be? Like, is there a set distance between picking one site and then, like, what makes a second site? Like, is there a distance?
We don't use any sort of distance to determine that. We just kind of, they're based on, here, I'm trying to find one of my better maps. It's based on the restoration areas that are already taking place. And then the sites themselves, like Leo's Landing is, I guess, one of our bigger sites because it's that whole thing. But we don't actually, like, we can't actually seine in the wetland portion because there's so much plant material and everything in there. So we're doing more of like the bay side of Leo's or like the tip of Leo's.
Would you ever think about going further up, like Thompson's Bay is where you found the mussels, like, but closer up to Gold Point, you know, before the, have you thought about?
We are trying so
Okay,
hard to get up there.
Okay, I was just curious.
Yeah, we've tried really, we like went trekking through the woods this summer, dragging 2 interns with us.
Yeah.
But the paths to get to like this side
Yeah.
are,
There's the beaver dam there, and then you have to hike over.
yeah, it's,
Yeah.
I would, if anyone has any info on how we could get in there better, that would be great. We
You gotta take a canoe across.
I was gonna say,
Okay.
canoe
That
is,
honestly would be the best, quickest way to do it.
yeah.
well, we'll see about the reality of adding a canoe to our mussel sampling. That, I would really love to at least look at
You
it.
can at least canoe there and
Yeah.
dock and then get out.
Yeah.
And do it, yeah.
We can canoe, we can see if they're there, because if they're there, I would really like to take a look at what species are there, if it's the same ones.
Right.
Yeah. Anything else? All right, thank you very much.
I don't know where my top got put here.
Okay. Yeah, you've got like 3 minutes, so then I'll introduce you. Thank you.
All right. For our next presentation, I would like to introduce Sarah Sargent on 7 years of marsh bird monitoring at Presque State Park 2023 update.
All right, thank you. Do I need to talk into this, or doesn't matter? Okay. Okay. Well, thank you very much. It's good to be back yet again, another year of updates on this wetland restoration work that we've been doing. And for those of you who've seen the last couple talks, this is part of the same project. My part of it, or Erie Bird Observatory's part of it, is to monitor the secretive marsh birds that we believe are mostly, we want to try to establish whether or not they are using these marshes. And so Christopher Lundberg, who you see here in the kayak, is the guy who actually goes out and does these surveys within 3 hours of dawn. And in this year, I got my husband, Ron Mummy, to do some statistical analyses. So I don't know what my role is. I just stand up and talk about it, really, and do the interpretation, yes. So marsh birds, marsh nesting birds, I'm going to talk a little bit about them, but overall, what we're really interested in trying to get at is whether these relatively rare and secretive birds are actually responding to the vegetation changes that are happening as a result of the control of the invasive plants at the site. And so we have been doing this. They do require specialized survey methods. These are birds that are highly secretive. They're hidden. They're not well sampled by standard, like typical bird watchers or point counts or any of these other methods that are used for sort of normal birds. I'll say normal, and kind of different groups of birds need to be counted up and sampled in different ways. But this particular batch of birds is really hard to get at because nobody ever sees them. They're active at night, and they're in these habitats that are very difficult to get through, to navigate in. And so but at the same time, these are a set of birds that are highly endangered and have been declining for a couple hundred years, really, mostly because of habitat loss. They're very, very tied to marshes with emergent vegetation like cattails and that kind of thing. So this is a sort of an at-risk type of habitat, and these birds are considered to be pretty rare. So we sample for 8 species. The list is down here. And they're all considered to be species of greatest conservation need in Pennsylvania, or more rare than that. And so this is the set of birds that we're looking at. Now, I will say the ones down at the bottom are ones that, the last two, we don't ever get them, but we're still hoping someday we'll get them here. They should be here, we think. And they are can be here during migration, but not for breeding. So we're primarily concerned about the breeding populations of these birds. That's what we're sampling for. And so here's the bird quiz part of the talk. All their names were listed in the previous slide. That's an American coot, a pied-billed grebe, a least bittern, Sora type of rail, common gallinule, and king rail, American bittern, and king rail. So these are the eight species that we've been trying to detect. And like I said, it requires a special protocol. There is a standardized protocol that's used for across a lot of agencies and throughout North America. Everybody tries to use the same protocol so that we can compare data from all these different sites. And so the standardized protocol basically is you set up this series of points, and I'll show you the map of our points in a minute. They're out in the marsh, and they've got to be at least 200 meters apart from each other. You go out within 3 hours of dusk or dawn. We always do dawn here. And you do a playback. So you have basically a loudspeaker, and you Well, the first thing is you wait and listen for 5 minutes, because sometimes you'll detect the birds calling already. So first of all, you have to wait and listen for 5 minutes. You get your stopwatch going. And then you go through the series of calls in a particular order, because there's research shown some birds will respond to other not the same species more than others. And so there is a specific order that is followed by everybody who uses the standardized protocol. And then there's 30 seconds of calls from a particular species, and then 30 seconds of silence. Then there's 30 seconds of calls from the next species and 30 seconds of silence. Anyway, so you go through the whole thing. And and actually here I have, I don't know whether this is going to work. Oh yeah, it is. Maybe. There should have been calls.
Can you make the calls for us?
I don't know, the background noise is there, but it's weird. Did you hear it? Yeah. Anyway. Oh. This is the second type of call. It's a dit-dit-dit. It's not a very big. Well, it's weird. The first one is much louder than the second call. This is the quieter call. Oh, well. Yeah, we're into the 30 seconds of silence, so forget that. Okay. So anyway, that was, yeah, I don't know why that wasn't cold. Anyway, so then we go back to the same point either 2 or 3 times during the season. We try to get to them all 3 different times. So over the years, here's our points that we visit at Presque. When I say we, that means Chris, not me. But this is where when we first started the project back in 2017, we had just 35 different points that we were visiting, and in part that was because those are the only places we could get to. And so as more areas got more opened up, we added additional locations for these marshbird points. For the last 3 years, we've just stuck with the same set of points. I will say that this red color here, we added a whole bunch of, we were kind of hoping that some of these birds would start using Gull Point out there, but they really haven't. So in 2019, we added a bunch of those red points that have not been very productive. Anyway, so we've been ahead of the Bay area, Leo's Landing. This is the marina. Oh, sorry, no, that's the Marina Lake. The duck pond, then the bridge is there, and then this is Long Pond, Big Pond, all these other interior lagoon spots. That's kind of our core habitat, that big set of wetlands in there. Then this is Niagara Pond area, and then the Thompsons Bay area is here. So yeah, we had a point there in 2018. It really doesn't show up very well here. And then those other ones there. We used to have some additional points off of Leo's Landing back when there was actually Cattail Island back there before the high water years of 1920. So once those cattails disappeared, we stopped. There's no habitat there, and there's no land there. There's no vegetation there, so we do not sample there anymore. Anyway, so here's what we found. And I will say I'm going to focus on 3 species. There have been, these are the 3 most abundant species that we get, and we get these every year. All the rest of the species either never occur, king rails and American bitterns never occur, or we have never detected them yet in our 7 years. The other 3 species, the American pied-billed grebe and the sora, are quite intermittent. We'll get 1, maybe 2 in one place in 1 year, but they're not regular. So we really can't say much about them at this point. They're just too rare. But these are the 3 that we could do some analyses on and look at. A is the least bittern, and This, these bars, basically this is the mean count per survey in each year. So there's lots of surveys. We go to, one of our 57 points and there's no response by a least bidder, and that's a 0 for that. So it's how many individuals there are per survey in that year. So this years go from 17 through 23. And we have definitely had, least bidders is the most abundant of the species we have here, but they have declined actually through that time period. Gallinules have bounced around a bit, and it's unclear really what's going on with them, but they're certainly here every year. They're just, although haven't been ever as many as there were of the least bitters back then at least. And interestingly, Virginia rails have come in. We didn't have any, or maybe we had one, I guess, the first year. But it was just a little tiny blip. And then since then, we've had quite a few more. We had a lot in this one year. And that was the high water year. So 19 and 20 were the years where the lake level was really, really high. So in some ways, I think the lake level confounds the changes in vegetation. So it's hard to tease apart what's really causing it. So, but I will say we have attempted to, oh wait, I'm not going to talk about the vegetation quite yet. There's a little more detail on the stats. So this is just basically GLM, generalized linear mixed models, and it is in fact true that there has been a significant decrease in the numbers or the density of least bitterns over these years. The only other thing that's significant, time of day, turns out that maybe we don't need to go out that early, it looks like. For this species at least, they seem to be even slightly more active a little bit later than they are right at dawn. Kind of interesting. No effective cloud cover with wind speed and noise level. You're less likely to detect these, which is understandable. Their call is kind of a little bit not as, doesn't carry as well as some of the other ones do. So that's the kind of survey information, weather factors. Common gallinule, this species, there was no significant anything effect of these factors that affects them. There has not been a significant change through the years or at time of day. And these are the trend lines down here. Nothing is significant in terms of affecting the number of birds detected. Virginia rail, it looks like time, again, time of day is a significant factor in terms of picking up on those. And again, the wind and the noise levels can, higher wind and more noise make them less detectable, which is not surprising. Yeah, so there's been a positive, they really seem to be more detectable a little later. I don't know. We followed the standard protocol because other people elsewhere determined that that was when they were, that they would be best detected close to dawn. And they are active at night, and so it's a little bit surprising that we found that. All right, so to help us make sense of this, we started doing these habitat surveys. When you're out in the marsh, everything kind of looks the same and you can't see very far because you're usually like sitting in a kayak, and so you're down in the vegetation. And so the sampling area, the area that gets sampled by the doing the playbacks and detecting a bird, we estimate that could be as much as 100 meters, depending on how loud the bird is, whether the bird up and flies, which they do sometimes. So we're detecting birds over a pretty large area through their sounds they're making, but we can't sort of sample the vegetation very accurately over that scale. So what we did was we set up a grid system at 50-meter intervals. And in this case, when I say we, I mean Sean, so the GIS. The grid points, I'll illustrate it here. So these are, the red circles are showing the 100 meters around each marsh bird monitoring point. And by putting that set of grid points in, so any particular marsh bird point is right in the middle there. That's what we have to get to do that playback thing. But then we're going to look at the vegetation in a 5-meter radius area around each of those other points. Okay, I'm ready, I shot. And then, so we get somebody to go out to each of those little white circles all over the place out there. So that is the hard part, actually, navigating to the grid point to get to that point, slog through the marsh in the kayak or with the waders, whichever. And then it's just a visual assessment of what the cover types are. And we break it up into these different categories, but I will say how much area has standing water, that's independent of cover. So there can be water underneath the vegetation, right? If it's emergent or if it's woody, there can be water standing and still have vegetation above it. And so that question is just how much of the 5-meter circle area around you when you're at that center point, you eyeball it and you say, is that like 100% submerged or half of it, whatever. We have these categories here. You just try to get it into one of these categories and you record that. So the rest of these, how much of it is actually open water? That's a different question from submerged. And then this type of, these sort of categories of vegetation, is there emergent, is there woody vegetation, or is there other? Other turns out it's not always vegetated. There could be bare sand, there could be like a mat of dead things, and we're counting that as not the same as live things, right? And then we also were looking at the presence of invasive plants, and we had a couple. We just had 3, I think. Narrowleaf cattail phragmites and loosestrife, purple loosestrife. So anyway, what did we find? So now we only did these complete vegetation surveys in 2020 and 2022. So we only have 2 years of vegetation data. And so this is what it looks like though. Each dot is well, we only did the vegetation surveys once per year. So once, if a least bittern was ever detected at a marsh bird survey point in a given year, then the vegetation associated with that, so that would be like 8 or 9 or 10 points within those bigger circles. That gets averaged out, and then it gets put into one, it's on this side then if the bird was present. All the other points where there was never any least bittern detected in either of the 2 years, all those points are over here. And this is the average of the water cover that's under the vegetation. So clearly the least bitterns, and this is just descriptive, okay? This is, the mean is in the middle there, there's 25% quartile above and below, and then the full range, the top and bottom lines. But you can see that the mean, so I haven't done any stats on this yet. No real statistical testing here. There's a ton of overlap though, but you can see that there's a higher mean. Where the bitterns are present, there's more likely to be standing water over like an average of 90% of the point, rather than 60 to 70 in these other average in the other points. And so on with these other ones. So standing water is really important to all these birds, maybe a little bit less so to the Virginia rail, so they only have short legs. The next one to look at is the presence of emergent vegetation. And yes, indeed, these birds really do like emergent marshes. I guess this is not groundbreaking, honestly, but there has to be, where they're found, there's more likely to be a higher average. And woody vegetation is not preferred by any of them, not surprising. And then that other category of mud or whatever, they don't seem to like that much either. So none of that's that surprising. So in conclusion, lease bitterns have declined significantly since 2017 in terms of their density per point. The other ones that we really, the other ones for which we have enough data, there really wasn't a clear, no significant change. And we still need to do a little more work on that vegetation stuff. So, and we're going to keep on monitoring as long as we have the funding to do so. So that's all.
If you guys have questions, we will have time after this session. But we do have
I talked too little, sir.
That's okay. All right, for our last presentation of the session, we have Sean Dalton on aerial drone surveys of shoreline change and primary wetland habitats on Presque State Park, Erie, PA.
Thank you.
You're welcome.
All right, hello everybody. As Haley said, my name is Sean Dalton. I'm the lab and field manager here for the Regional Science Consortium. I'm going to touch on the wetland restoration slightly, but for the most part I'm going to be talking about some of the drone surveys that we do. Before I get into that though, I'm going to go over a little bit of a brief history of northwestern Pennsylvania's natural history. If you're not familiar with the geologic formations in this area, everything's glacial basically. So around 20,000 years ago in the last ice age, all of these purple formations that you see across the northern part of the state were all formed by glaciers. So the ice sheet that actually caused all of this was called the Laurentide ice sheet, came all the way from the Arctic Circle, came all the way down here. Specifically the lobe that carved out Lake Erie was called the Lake Erie lobe, so pretty aptly named. As you can imagine, a giant mile-tall wall of ice, anything that it's carrying when it begins to melt is going to drop exactly where it's holding it, which is why if you drive around the southern parts of the county, sometimes you'll see giant granite boulders hanging out in the woods. Granite is a result of volcanism. As I'm sure a lot of you are familiar, there are no volcanoes around here. So what those actually are bits of the Canadian Shield, which is a large granite formation bordering Hudson Bay all the way up there in northern Canada. So just a little fun fact that I like to throw in there. This other arc of lakes that extends up into Canada also were formed through the same process. So if you're vacationing in Yellowknife, that lake is also formed through the same exact process that formed the Great Lakes, but it gets way colder up there, so not a lot of people tend to go and visit them. So that brings me to Presque Isle itself. It's composed entirely of unconsolidated glacial sediment, which means it is a bunch of loose sand that was just stuck in this glacier. There is no bedrock formation that gives the peninsula its shape or keeps it where it is. It is just a result of the erosive forces of the lake pushing it and leaving it there currently. It's thought that the original deposition area of all this sand was about 30 to 50 feet below where the lake level currently is, and then just over time it's been pushed to where it is. If you're familiar with this area, 9 times out of 10 on any given day, if you go out to the beach, our wind is coming out of the northwest. Because of this, our waves also come out of the northwest. This leads to something that is called a longshore current or a longshore drift. So if you pretend you're a little sand grain hanging out in Lake Erie and you get pushed up onto the beach at an angle by a wave, you're going to be carried at that angle, but due to gravity, you're going to then wash back down into the lake at a perpendicular angle to that slope. Because of this, over time, the sand tends to migrate from west to east here in Erie. So you can think of the peninsula kind of like a giant slinky is how it wants to move. And if you look at this figure over here on the left, which is a historical figure from the U.S. Army Corps of Engineers, you can see that over time it's kind of just been migrating from west to east, kind of like a slinky. So Gull Point out here will want to extend, connect to the mainland, and then you can see in the past the neck has actually breached and the peninsula wants to continue moving that way. Now, since humans have been here and we found out what a great harbor that Presque Isle provides for itself, we've been desperately trying to stop that ever since we've been here. One of the biggest things that we have done in that effort is the addition of the breakwaters that you can see off the shore there. This was about a $35 million project that was approved in the late 80s. If you go out to Beach 10 and look, the three final breakwalls are really low in the water. Those were actually the prototype breakwalls that were put in the early 80s to see how that beach face would react to that. And it gained a whole lot more sand, so they put them across the whole rest of the peninsula. The way that these work is quite literally as a wave attenuator. So if you figure if a wave hits a wall before it hits your beach, it's going to hit the beach with a lot less energy and take less sand with it. I did not include the figure in this, but if you look at historical replenishment costs from the mid-'80s to the year post adding these, it went from about $5 million to about $1 to $3 million. So it did have a pretty significant impact on the amount of sand that needs to be replenished yearly. So sand is replenished through the beaches throughout the summer by DCNR. They handle all of that. There is a large sand pile at the North Pier that is either dredged or dug out from other structures along the peninsula where sand is collected. And the price of that ranges from $1 to $3 million every year, depending on the amount needed. We also do get 5 million visitors here about every year, most of them coming to recreate on the beaches. So considering how many people coming here, that's not that significant of an amount of money for how much money the beaches bring in. That being said, there's all sorts of modern issues that we have on the beaches as a result of some of the structures that we have out there that prevent erosion, but they're not without maintenance. So one of these things that happens is what's called a tombolo, and if you've ever seen that, that is when this bridge of sediment kind of reaches out from the beach face actually to the midpoint of that breakwall. The reason that this happens is as those waves enter on either side of a breakwall, they form their own wave pattern, and when those wave patterns meet on that interior side, the energy cancels itself out and all that sand just falls out of suspension. So once those connect, they will actually cut off that drift of sediment from the eastern side of the lake, or western side of the lake, sorry, and it will start eroding the eastern side of the lake. So that, and the beaches don't get dug out significantly on one side. I do have a picture that I will show you later on that shows that pretty nicely. Which brings me to the drone itself. So the drone that we use is a DJI Phantom 4 Pro V2. This is a pretty standard consumer drone. If you were to go to Best Buy today, they probably have some of them on the shelves if they haven't been discontinued at this point. We were at a conference a couple weeks ago, though, and it seems like a lot of these stuff are currently at the point where all the new versions are coming out. So there might be a new one of these. Out of the box, it does come with a 4K camera. It takes really nice pictures. Usually at the altitude we're flying, we get about 2 centimeters per pixel in our final image, which allows you to really zoom in and get a lot of detail out of that. We do also have a secondary sensor that we can mount on it that looks at orange, cyan, and near-infrared light, and that allows us to do some vegetation analyses, which I can go into a little bit later. Now, flight stipulations and testing. In Pennsylvania, on any state park land, or if you're flying a drone for any type of compensation, you do have to have a certificate from the FAA Part 107. When I got my license, this did require an 8-hour course that you had to go and take at the airport. However, now they've updated a lot of this, and you can do a lot of your schooling online, and then you just have to show up and take the test at the airport. So it's a little bit more streamlined now. After that, you do have to get a letter of authorization from the park and let them know about any and all of your flights that you are doing. And there's all sorts of other fun regulations, such as no operations over people unaffiliated with your mission, which, if you can imagine trying to do a survey of a beach that has 5 million visitors in the summer, can be a little challenging. So generally when we do that, we have to get out there very early in order to beat those crowds. Also, wind speed, altitude, line of sight, and airspace regulations can all be challenging. The Erie Airport has a 5-mile radius directly from its control tower that you're restricted areas that you're able to operate within. So about halfway out to the park, in between the waterworks ponds, is where that cutoff starts. Anywhere closer to town that you want to fly on there, you have a ceiling of about 50 feet. With trees in the area, when you're trying to do a survey, that can be difficult. If you're not flying twice the height of whatever your highest object is, you can have some parallax issues, and that tree will look like it's at a whole bunch of crazy different angles in your final mosaic. So unfortunately, because of that, some of the sites that are closer to town, we can't fly on those just because the data won't be usable because of that altitude. Another fun little thing that I like to mention in here is that originally when I was taking the test for this, it was 2021, and my test was scheduled for March 18th, which was the day everything shut down in Erie. So that was fun. These are some of the targets that we've hit. So this is a satellite image, but if you look, this overlaid image up here, this is the drone imagery overlaid upon it. So we've gotten from about Gull Point all the way to about the lighthouse in terms of shoreline, and we're continuing to monitor those areas, as well as out here at Thompson Circle, we have also taken some flights of that wetland restoration area. So moving into some comparison images, this is out at the Beach 9 area. So on the bottom here is satellite imagery from 2012, and this is a drone image from 2020. I really like this image here because you can see that completed tombolo all the way out there to that break wall, and it really just shows how that can lead to that erosion of that down current side of the beach face. Just because since this sediment's all collecting here now, there's nothing here replenishing this as all that sand's being carried away. Heading a little bit east of that location out towards Gull Point, this is another spot that I like to show because if you can see here, the drone imagery is significantly farther south than that 2012 satellite imagery. If you measure that, that's about 70 feet directly south. However, that sand isn't gone. It's collecting out here at the end of Gull Point. So you can see underneath there in 2012, Gull Point was much shorter. So that's just collecting more sand there. So that's that slinky effect. It's continuing to grow out there. Here's one of our habitat areas. This is one of the ones that I really like to choose because a lot of the times when you're accessing free satellite imagery online and you're not commissioning it yourself, you don't often get the options of time of year and when exactly you want it. So if we're looking at vegetation in the wetlands and the only thing available was taken in March when there's no vegetation growing, that can be somewhat of an issue. So you can see just how much of a difference there is in the quality of imagery with the drone. It's very easy also to go out there, do a flight in the morning, and have that map that afternoon. So just the ability to get new spatial data that quickly is very powerful. So going into the wetland habitats a little bit, here's that same picture, just a little bit closer. That's out at the Thompson Circle area in between Beach 10 and Beach 11. And what I'm able to do with that second sensor that I mentioned earlier is what's called an NDVI, or a Normalized Difference Vegetation Index. Essentially what this is just a visual indicator of the health of a plant. So plants during photosynthesis really like to absorb pretty much everything except for green light, and they reflect a whole lot of near-infrared light as well. So if you were to go out and you were to spray an herbicide on a plant and look at it 24 hours from there, to your eyes it might not look very different. However, if you were to look at it with a near-infrared camera, it would be absorbing nearly all of that infrared light at that point. So using those reflectance characteristics, you can apply a color ramp of red to green, and you can basically quickly at a glance see, all right, this is stressed, this isn't. So in the case of applying herbicides or removing invasives, you can then use that information to more accurately treat your target species. Traditionally, these analyses were done with red, green, and near-infrared. However, they're transitioning now to using orange and cyan, just because, as you can see in this filter, it gives you a little bit more contrast in areas where you have open water or exposed dirt, which when you're working in a wetland versus an agricultural field, you do have a lot more of those things. So this tends to be very helpful. So this is the side-by-side comparison of the visible light and one of those NDVI images. And so just seeing that quickly at a glance, you can figure over here is a lot more healthy than, say, along the edges here where there's more dirt and things like that. The orange and red represents the open water. And so if you have multiples of these from successive years, you can really quickly at a glance see how your site has changed from year to year. Image processing for this is really great because it's super simple. All of these apps for controlling the drone work through a tablet and things like that. When you're opening it up and programming a flight, it quite literally looks like you've opened Google Maps, and you can draw a square and it pre-programs all of your flight paths for you. Everything is saved on a micro SD card on the drone, and there's an accompanying website that mosaics everything for you automatically. So in terms of processing, it's a really hands-off thing. You just upload it all to a website, and a couple hours later they send you an email with all your processed information. So that's been very convenient. It says that it can take up to 24 hours, but I've yet to submit something that I haven't gotten back that afternoon. So that being said, there are a lot of difficulties. As I'm sure a lot of you are familiar with the weather in Erie, it can change pretty quickly. Also, operating over people has proven to be an issue in the past, just because sometimes when you hike all the way out to Gold Point. You spent an hour getting out there in the morning. You finally get it up in the air, and then you have to land it because somebody walked by for 5 minutes. And you got to send it back up. And then going along with that, the batteries generally only last for about 30 minutes. We have 3 of those currently. We've been talking about getting more, but they're expensive. They're over $100 each. So just by the nature of it, sometimes when you send something up and it's been up there 10 minutes getting to where the survey starts and you have to bring it down, sometimes you can spend your battery avoiding people that are walking along the beach. Wind speed's another one. Sometimes you're on the shore and it feels like it's a typhoon, but 200 feet up there's nothing, and vice versa. We've had times where we're out there where it's totally calm on the beach and you literally can see the drone being pushed out of the air and it gets a little scary. But yeah, time of year also can be a difficult thing because in terms of doing an NDVI analysis, your peak vegetative photosynthetic period is like the second week of July, which is also a very popular time for summer recreators. It's also a very busy time of year for us because one of my other portions of my job is overseeing the interns who collect all of the samples along the beaches. So a lot of times I'm tied up doing other things and can't necessarily get out there in the morning. And then COVID-19 threw in a whole bunch of fun extra difficulties that we had to get over. But yeah, that about brings me to the end. I'd like to acknowledge some of our project partners, DCNR, Go Native Erie, Penn West University of California, and the Erie Bird Observatory. And I think I have some time for questions, don't I?
Yep.
Also take any frog questions too. Yeah.
So on that drone along with the camera, there must be a very accurate GPS, so it knows where it is kind of second to second.
There is, and you can actually get upgraded versions of this with a real-time kinematics unit on it. It's a couple extra $1,000, but then you're literally getting centimeter accuracy to your things. So if you wanted to adopt it for like engineering practices or something like that, there are those options. All right, thank you.
You showed you showed Gold Point there,
Yeah.
and then kind of looking around. And maybe other people here know, or you do from being out there, but boy, from the lake, if I launch at East Avenue this year, it looks like Gold Point is really hooked around much more to the south. Has it? In like just the last year or two?
Yeah, shallower too, like there's a lot of sand underwater, it's like going shallower.
Yeah.
The position there in the sky.
It curves around and it's extending further south.
Right, yeah, it's supposed to be more to the south.
In the past,
Quite a bit.
in the past, from what I understand, from what I've been told, Brian Goulas told me this, that in the past it's actually connected to the Beach 11 area, and Thompson's Bay has become like a lake historically. So it might be trying to reach out and do that again. Gold Point is one of the areas that I've been constantly trying to get the entirety of it, but it's a lot bigger once you get out there than you realize, and because of the important bird area, it's a very limited time of year that you can get there. It tends to be when it's cold, and when it's cold is when I tend to get the most issues with the drone, just technologically. So it seems to not like being out on the exposed sand in the winter when the wind's blowing. It's when it gives me problems. So it's when I drag Sarah out at 7 in the morning, we hike out for 45 minutes, and then the drone doesn't work.
Or we forgot something.
But yeah, it's definitely significantly larger out there now. All right.
Thank you, Sean. And that actually concludes this session. The next one will be in 10 minutes, so feel free to go to the bathroom, get a snack, whatever you would like to do.
Yo.
officially on time now. All right, we're going to start this next session. Our first presenter is Emily Pritchard. She's with PADCNR, Presque State Park, and she's going to be speaking about shifting into steels, an overview of the Presque EE staffs transitioning their lessons to fit the new PA Steels standards.
Hello. As mentioned, my name is Emily Pritchard, environmental educator for the Department of Conservation and Natural Resources here at Presque State Park. Myself, along with my education colleagues, John Laskos, Alyssa Zimmer, Brian Gula, Stacy Morant, Ray Bierbauer, Ann DeSaro, and Holly Best, have been working to shift our education styles in our field trip program offerings. This shift is a result of the new Pennsylvania Academic Standards for Science Education, known as STEELS. STEELS stands for Science, Technology Engineering, and Environmental Literacy and Sustainability. Academic standards are statements of what students are expected to know and what they are expected to do at certain grade levels, and they're nothing new. Pennsylvania, along with many other states, started incorporating academic standards in about the mid-1900s. Generally, academic standards are broken into subject matters, so English, math, science, and so on, and taught either as separate topics or together as a cross-curriculum. Each state is responsible for establishing their own set of standards. However, there are some federal guidelines or federal models that exist for some topics. The Pennsylvania STEELS standards guide the study of natural and man-made world through inquiry, problem solving, critical thinking, and authentic exploration. These standards were adopted by the Pennsylvania State Board of Education in January of 2022, so they're relatively new, with a goal of full classroom integration by the 2025-26 school year. They replaced the older science and technology and environmental and ecology standards that were set in place in the year 2002. STEELS are aligned to current research and best practices in science education, and they prioritize a shift away from the memorization of facts to having students productively participate in the science process. They're organized into grade levels, so just like they have been traditionally, but they are designed to be more of a transitional style of teaching that builds on experiences from year to year instead of having sort of those separate guidelines for separate grade levels. Within STEELS framework, there is 3 dimensions that serve as building blocks for these standards. Those 3 dimensions are the disciplinary core ideas, cross-cutting concepts, and science and engineering practices. Together, this 3D learning gives teachers an opportunity to have their science classrooms be very engaging, intuitive, and really reflective of real-world scenarios. It is a way of teaching that is as close as possible to how scientists is naturally aligned with Pennsylvania State Park's environmental education programming, and therefore DCNR's outdoor programming division is spearheading efforts to ensure that STEELS is incorporated statewide. Here at Presque, our team has begun the journey of shifting into STEELS by piloting an advanced field trip opportunity for several school-aged groups. Our personal transition path started in the year 2019 when we started incorporating inquiry-based programming into our field lessons. Inquiry-based is just a form of science education that is really centered on the student-driven learning instead of teacher-centered learning. So it puts an emphasis on the kids' curiosities, the students asking questions, and the students leading their own investigations to answer those questions. Inquiry is largely woven into STEELS, and therefore it's a very seamless transition and a great first step into the STEELS standards. So we piloted 3 separate inquiry-based field trips here at Presque, And the programs were a modification of our well-established sand investigation field trip that we have been offering for a number of years. But it traditionally followed a more conventional style of teaching. Our pilot groups were 2 mixed-age homeschool audiences and 1 middle school classroom audience. And the goal was to lead these groups in student-driven investigations that would examine the natural and the man-made aspects of our beach environment. So we guided the students through a series of steps, and step 1 was recording the curiosities on a wonder wall. We provided a very brief overview of Presque State Park using our park map, this picture up here, and some relevant touchable objects that the kids were able to get their hands on and pass around. And they recorded their questions and curiosities on little sticky pads that we then put up on what we called a wonder wall. We put it up for everybody to see. We reviewed some of the notes out loud right then and there. We addressed some of them at the beginning, but we also sort of had this up there or something that we could revisit as the day or the days went on. And their questions and their curiosities really ran the gamut of Presque Isle. You can see them up there. I wonder if people can fish on the park. How much water is there? I wonder where turtles go in the winter. So they had some really good thoughts. Our second step was exploring the resources with a See, Think, and Wonder activity. We led the group to the beach, giving them time to just self-explore the habitat and record things they saw, think, and thought on an activity sheet here. This activity obviously builds on the first one, the wonder wall, but it helped to focus their questions and curiosities to the beach habitat specifically instead of Presque Isle wide. They came up with some really good things. They were asked to say, what do you see, what do you think about, and what are you wondering about? This led very nicely into step number 3, which is a question builder activity. They formed questions based on their See, Think, and Wonder, and these were your basic who, what, when, where, how questions. And step 4 was to take those questions and to form it into an investigatable question. So we helped them take those who, what, when, where questions and actually put them in a format that has a question that they could do an actual investigation or research question into. They wrote those questions on long strips of paper. We put them up on the wall so that we could then read them out loud. We could help them reform them if they needed. They could see what other questions their colleagues came up with, what their peers came up with. And interesting to note, for 2 of the 3 programs, we, the educators, actually gave a very specific directions to the students for their investigation. We wanted them to help us look at a resource management issue on the park, and that was sand erosion. And so for those first 2, we actually asked the kids very specifically, record your investigations related to what influences the beach, either natural or man-made, and the potential relationship between those influences and beach erosion. So they came up with some very specific questions. Are the rock structures preventing the erosion? Which substances are not greatly affected by erosion? And then that they were talking about like what particles in the sand. For the third group, we kept it more open. We let them create questions on anything related to the beach. We didn't give them sort of the resource management aspect of it all. And that was mainly because our third group we had a lot less time with. So step 5 was planning and carrying out student investigations. This is where the fun happened. We provided them with a variety of equipment, and you can see a picture up there of just some of the things we gave them. And as a team, they needed to design an investigation using just the provided equipment that would help them answer their questions. This is, again, where the kids really had fun. They were out there hands-on, using the microscopes. I think the favorite aspect of them tool that they had was our metal detectors. We really had to, once they saw they had metal detectors, a lot of the kids were changing their investigation question just so they could use the metal detectors. but they had a wide variety of tools. And then, of course, after carrying out the investigation, step 6 was analyzing and interpreting their data. So time was given for the students to do this, and education staff was available to help them through this. And it wasn't that we were there, telling them the answers or giving them more information. This came in the form of more of a conversation, and that conversation was very helpful because, as the adult, as the educator, we did have more background knowledge. We had kind of an idea going into this, what they were going to talk about. So we were just really able to help them to guide them through understanding what maybe some of their data meant. The next step, step 7, was constructing explanations into presentations. And this was just as it says, they took their data and they were able to create presentations. We gave them free range of what that presentation might look like. They could do a poster session like you see in the picture. They could do a PowerPoint. They could have done an interpretive dance. We didn't care. We just said, somehow present to your peers what it was that you investigated. So step 8 was the actual presentations. And through our 3 pilot programs, we had a wide range of time. So the first one, the kids actually had a day and a half to create their presentations. That first pilot program, we worked with these kids for 2 full days, and then there was a day in between. So they had time while at the park and then the whole next day at home to create their presentations. Pilot program number 2, they had 2 hours to prepare, and the third group only had 30 minutes. So after the presentation, the final step is group discussion, and this is a very important step to the inquiry process. It helped the students to see the big picture formed from all their individual investigations. It tied everything together and really made their investigations relatable and relevant to not only themselves, but as a team as a whole. So in conclusion, after doing these 3 pilot programs, we were able to come up with some successes, some difficulties, and of course, some future goals that we have. First off, the successes was the student involvement. That was number 1. And along with their involvement came student investment. They were 100% involved and 100% invested in their own learning, and I think it was because it was their own idea. They had a lot of ownership over what they were doing. We weren't just handing them a piece of paper and say, fill out this worksheet. It was, what do you want to know? Well, let's figure that out. Another success is that we were actually able to get real data, especially when it came down to the 2 groups that we gave them a resource management issue, and they went out and figured out some data for us. Was it something that we already knew? Yeah, maybe because of time constraints, we didn't get into it very deep. But with a new set of eyes and young eyes, they were able to come up with some great questions and some great insight for us that we wouldn't have thought of. A couple of our difficulties, number 1 was, I mentioned, the time constraints. This can be a program where you really get in depth with kids, and the school groups coming out here don't always have that 2-3 days. So we were able to modify a lot of this down from the 2.5 days down to even to a couple hours and still have that experience of ownership, that investigation for the kids in a very successful manner. It requires, as you saw, a very wide range of equipment. So it was something that we had to sit down prior to and really think like, okay, what are these kids going to want to do? What can we offer them? And of course, in the end, they can only use the equipment that is provided to them, so they have to work within that constraint. But we really tried to just, blow the doors wide open and give them anything that they would need. And another difficulty, which I think was just personally for me, was sort of like a knowledge constraint. Like I was kind of worrying at first that I didn't know everything there is to know about the beach, and we weren't focusing on one thing. And so as a teacher, you kind of go into teaching thinking, I want to know everything. I want to be the expert. I want to be able to answer all the questions. And with such a wide open topic, you really you gotta know that you're not going to know it all. But it was okay. It was actually not difficult at all. It was something that turned into more of a conversation, like I said, and so even if we didn't know all the answers, it was great because the kids were so invested anyway. So from that, some of future goals that we have for shifting our lessons into steels is to really dive deeper into the steels themselves. As I mentioned, we kind of softly went into the inquiry-based. We are really diving into what the steels are and wanting to align more of our sand investigation experience to the steels. We want to shift yet another established lesson, which is the pond that we've had for a number of years that we offer to students as a field trip. And we want to put that into the steels framework. We're going to continue piloting both of those, the sand and the pond, through the spring of 2024. And as we're doing that, we're also collaborating on trainings. One training we're going to collaborate with the local IU5, so the Intermediate Unit 5, to encourage other local environmental educators to make the shift. So we can sort of show them sort of the steps on how to do it. And through this all, of course, we're also going to stay in collaboration with the Pennsylvania State Park educators because this is where this is all being driven anyway. And we have multiple avenues for collaborating with them as this process goes forward. So if you're interested in learning any more about steels, if you go to the Pennsylvania Department of Education website, the one that's listed down there, they have what's called a Steels Hub where you can get all sorts of information regarding these new standards. If you know a school group or if you have a group yourself that would be interested in coming out to Presque for a free field trip opportunity in the spring, make sure you contact Ann DeSaro, our Environmental Education Specialist Supervisor, and we can get that on the books. And any other questions I can answer for you as well.
So obviously your student involvement is very good and they were very involved in that, but what was the response and the takeaway? Like, did you guys have any feedback for that?
From the students themselves?
Yeah, or
Yeah.
their teachers.
Yes. So most of our feedback, and it's funny, most of our feedback came from the third pilot, the shortest one. The first feedback came from the teacher who really kind of went into this blind. She didn't really know what she was getting into. She just said, hey, it's a free field trip, sure, let's go. Halfway through that, she stopped us and said, I'm sorry, are you trying to incorporate some of the steel stuff here? And we're like, yeah. And she's like, yeah, you definitely are. This is great. The students in that group, too, we had to pull them away at the end of the day, and they were asking to come back to continue their investigations. And so that was wonderful. So I think they really enjoyed doing it.
You might have already said it, and I might have missed it, but what age groups were you working with in these trials?
In the pilot ones, yeah. The first two were a mixed homeschool, so they ranged in age from, I think it was the third or fourth grade might have been our lowest, up to high school. And then our third one was a middle school, so it was fifth and sixth grade group.
Is there guidance or sort of emphasis, or how do you steer the kids to sort of a good scientific question?
Yeah.
And if you looked at the questions, you saw a lot of variation in, can some of these even be answered?
Yes.
Or, it's like a yes or no answer. Is that
Yep.
in steels?
Yes, so in the process for doing that can be a little drawn out with more student input, or it can be very quick. So for instance, the first one that we had where we had these kids for 2 whole days, their questions were really yes or no questions at the beginning. And it took a lot of guidance from the educators to lead them down the right direction. So even though it is very student driven, depending on your time, depending on your equipment, depending on really your end goal, yes, the teacher is still there to do a lot of molding and sort of guiding in the right way. And it helps if you have the time to help them realize what an investigatable question is and help them first learn how to ask a question, because their questions right off the bat often are very simple questions. They're not so complex. So if you have the time to work with them, and creating good questions is part of the standards for steels. So it's one thing they should have sort of a baseline for. Okay, thank you. I'll let you.
Okay, thank you.
I don't know where my folder went. Help me find it, help me find it. Where is it? Thank you. Yay. All right, well, we are ready for our next presenter. This is Haley Dahl. She's from the Regional Science Consortium, and she's going to be talking about enhancing environmental education through nature, Iroquois Elementary School's outdoor classroom.
All right, thank you, Holly, for that introduction. So I would like to introduce myself a little bit, give a little bit of background, because I did just start working for the RSC around a month ago, and there's a lot of new faces here. So I thought that this would be a good opportunity to formally introduce myself. So I'm originally from Western New York, and I lived in the Chautauqua County area. If anyone's familiar with that, I know we had a couple presentations about that. I actually am from Cassadaga, so if you heard the presentation by Jonathan Townsend, I'm from Cassadaga, and he was presenting on that as well. Another little correlation there is that I interned for the Chautauqua Watershed Conservancy, if you're familiar with that, and I did a little bit of similar stuff there. So then after I graduated in July from Coastal Carolina, I got this job opportunity, and just relating back to the CWC, it was sort of similar to that. So I'm sure all of you are aware of the RSC's mission, but I wanted to relate that to kind of introduce this new position that I was hired on. It wasn't entirely new. Sarah Magian, who's over there, actually used to do the education stuff for the RSC. But I got hired as the education outreach manager, and this is giving us a lot more opportunity to do new events and more events with our schools. So we have 36 member organizations, which include colleges and universities, state and federal agencies, school districts, and other nonprofits supporting our mission. So I'm sure you guys are all aware of some of the things we've done in the past, like the Forensic Science Escape Room, all those events, which are great. But with this new position, I have a lot more room for creativity and freedom to do more outreach to more schools maybe, and recruit more members through this as well. So if you just want to look at this mission, I wanted to point out that if you were in the last session, you heard some of the research that was done from Sarah and Sean, and obviously Jen as well. And so with this education position, I'm able to relay this and teach about the research that we do, because research wouldn't be effective if you didn't teach the outcome of it. So if we look at this map here, this is going to be the Iroquois Elementary School. I don't know if anyone's been there before, but this is kind of like right outside the parking lot here. So as you can see, these are the cars. So this outdoor classroom has been a work in progress, but we did get funding from the Department of Environmental Protection from their environmental education grant. And so we have a lot more room to do things and make this a bigger opportunity for the Iroquois Elementary School. So if you want to look over here, this is going to be a pergola, and I'm going to get into all of these as well. So I'll explain what these are going to be utilized for. And so we have the pergola over here, and then a bird feeder platform, and then we've got this French drain, which was to help with erosion mitigation, and then we have a purple martin house here, and then we have a bunch of different gardens that are going to utilize different plants, including native plants and different things. So a pollinator garden there, a rain garden, and a Shakespeare garden. So just some of the things to touch on. The project priorities include water, climate change, and environmental justice. which I will be touching on later in the presentation as well. And then these are just the stations that are going to be utilized in this outdoor classroom. So other than our water, our climate change, and environmental justice, we also always want students to have the connection of what they're learning to the Great Lakes, obviously, because we're on Lake Erie. So we will also be following the Great Lakes literacy principles. And if you're not aware of these, the first three are some of the ones that we always look back to, and that's why I have those ones in bold there. And so we have our connectivity to the Great Lakes, and then also natural forces formed the Great Lakes. And so some of our lessons will be talking about the history and also like the geologic formations of how the Great Lakes were formed, just so that students are always tying that back into the Great Lakes. Okay. So kind of the basis of how this is going to work is there's going to be a bunch of different stations that are going to be utilized by all the different disciplines in the school. So we didn't want it to just be for science classes or just for art classes. So the idea that we're coming up with is to have bins for each of the subjects that will have a lesson plan and everything that the teacher needs with little preparation. So I will be working with these standards to come up with these lessons for the teachers so it's easy access and they always can use it whenever they want. And aside from the interactive lessons, we're also going to be coming up with stuff they can do in the off season so that there's always the connection to the outdoor classroom. So the first one we're looking at is the pollinator garden, and we're going to be working with Jen, who's one of our native plant experts, and Dahlkemper's Landscaping to put in native plants to attract those pollinators. And then there will be a lesson involved with that as well. We have been looking at different catalogs such as Nature Watch, where the students will be making their own pollinator houses, and we're also going to be try to include recycled materials so that they're relating that sustainability approach back to the lakes and how that all plays a role together. So this was just a little idea. I kind of was thinking of an incentive where they could recycle things all year to be constantly putting stuff up year after year to kind of keep the maintenance of this outdoor classroom, as well as always thinking about how they can improve pollinators and how they can be coming and showing up. Our next one is going to be the pergola classroom, and the pergola is already on their campus. I didn't have a picture of the specific one, but it looks similar to this. So this one was kind of going to be an introduction to the outdoor classroom as a whole. So it was going to introduce the students to what is a watershed and how does your local watershed, how does that impact you, let alone the area that you're actually in, how does that connect to that watershed as well? And so they're going to have things like binoculars, there's going to be bird song, the identifier lyric, which is from Nature Watch. They'll have one of these posters to relate to. And then also to have something physical for them to come back to, we thought about doing a data log where if they saw a bird, they would positively identify it and then write it down on that sheet. Another thing to point out about the pergola classroom is that from the classroom you'll be able to see the purple martin houses, and I will be working with the Purple Martin Conservation Association to come up with lessons for that as well, because they've been working really hard on upping their educational material, and I would love to work with them on that. All right, now our reading garden. This was already established, and like I said, I don't have a picture of the one that's already at the elementary school, but it was actually inspired from the one in Central Park. I don't know if you guys are aware of that, but all the flowers that are going to be planted there are ones that are from Shakespeare's novels. And so we're hoping to post some signage there that will make the students aware of those plants and why they're there. And also, it will include literature from Shakespeare and other literature that will be talking about nature and science. And then another thing that we had an idea to do was include literature there that talked about environmental justice. So that would be promoted through this reading garden as well. So other than the books that will be there, it will be a quiet place for reading, and students can grab a book out of there and read it. And then we're going to build one of these little free library books as well. So as part of our physical education approach for this, we are implementing a yoga garden, and we will have yoga mats for the students to utilize there as well. There's this random idea going around where there's little flashcards that can all relate a yoga pose to nature. So this could be something that a phys ed teacher or any teacher could bring out, and they would just hold up the flashcards, and students could have a relaxing little yoga session out there. But this is a great one too, because your physical fitness and your wellness actually relates to nature, and that's part of your physical being. So in order to teach students about that, we thought it was really important to include that physical education aspect into the outdoor classroom. Another portion of this is going to be our writing and art. So this up here is just an example that I pulled from Pinterest of a little nature journal. So this is going to be something the students continue to bring back. So even though we have all these multidisciplinary stations, they will always have this. So every station that they go to, they'll have their journal, and they'll be writing down everything they see, basically field observations, and kind of tying everything back to nature and back to our priorities of water, climate change, and environmental justice. So they'll be able to brainstorm. I kind of wanted to take an approach where the students will implement a lot of the stuff that will be providing them the education. So we have this stuff over here where maybe there could be an opportunity for them to grow their own plants or maybe vegetables or something, and these are all just recycled milk cartons. And then these are sun catchers up here using pressed plants, which we do have a lesson on. That could be cool for the students to learn how to press plants and hang up those sun catchers. So like I said before, just always implementing stuff year-round into the outdoor classroom. And then this is also going to highlight the environment changes. So like I said, it's going to be year-round, not just in the warmer months. And then we have our rain garden, and now I'm going to be kind of talking a little bit about the 3 program priorities that I introduced. So something that we have available for students is the water quality monitoring station. And one thing that the RSC does through their education program is we work with a lot of gifted students. So we thought that this could be an initiative for them as a project to log the water quality monitoring stuff, and they would come back and relate to that, and then they could write reports on it and send the data somewhere. But the main thing that we want them to get out of this is the water aspect. And so we kind of introduced the topic of water being a limitless resource and not an overabundant one, which students sometimes have a hard time grasping. So this is kind of what we're trying to tell them here, and that it's important to be aware of the water quality status as well. So from this, this is the Iroquois Elementary School Garden Club, and this is with Jen, and they planted native plants to improve the school's retention pond. And so that's something that we're still going to be working on, planting more plants in there, and they'll be able to relate back to that as well. But basically with runoff and erosion, that's something that they'll be able to see firsthand, and we'll be able to teach them about the water aspect through that. So the other 2 priorities that we were introducing other than water are climate change and environmental justice. So students are going to be understanding what climate change is and activities that contribute towards climate change. So through everything that we do at the RSC, there's going to be also kind of like a stewardship action project where students are going to suggest ways of how they can mitigate climate change in the outdoor classroom. So this will be part of those crafts that they make and stuff like that. And then there's also community projects which go along with the stewardship. They'll learn about the stormwater best management practices, the rain gardens, habitat improvement, and the water quality monitoring, like I mentioned. And then for environmental justice, we really want them to have a grasp on what that means for them. And so ones that are local to them are the Lawrence Park Township and Wesleyville Borough. So we would love to get involved with more environmental justice communities to relate back to the students as well. So now I'm just going to talk a little bit about the benefits of this outdoor classroom. Like I said, this is an ongoing thing for us, but we want to make this something that students are going to get maximum efficiency out of. And so some of the things I wanted to highlight that are beneficial of learning in a natural setting rather than a classroom, especially in a suburban environment. cognitive development, learning, psychological well-being, independent learning, and obviously connection to the natural world. And nothing we do would be complete without a little MeWe, because we love those around here. But that, if you're not aware of what that is, it's going to be a meaningful watershed educational experience, and that's actually a standard from NOAA. I'm currently actually going through the training to get certified to be a MeWe instructor, if you will. And that's actually on their website, and anyone can do it. So if you're interested, I think that's something that's super important if you're trying to incorporate it into your lessons. But basically, it's to immerse students in their environment using a multidisciplinary strategy, which, like I said, we're trying to do that within the outdoor classroom. And then increase environmental literacy by actively engaging students in building knowledge and meaning through hands-on experience. So all the crafts they do, the little lessons and labs that they'll be doing, the reading, all of that stuff. And I know I'm running out of time, but I also wanted to go over a few of the other things that we've been working on, just for those of you who aren't familiar with it. And if there's any interest in any of it, you can always contact me. All of my information's down here. But we have our hackathon, the Forensic Science Escape Room, which everyone loves. This is a new one, and it's actually going to be integrating fishing into a curriculum, and we are looking for teachers in schools to help with that. So if you know anyone who's interested, if they could contact me, that would be great. And then we've got our 4 seasons of STEM, which is new this year, and it's going to be a 3-part because we're already in our 1st season. But yeah, we've got some cool things going on there. And then starting next week, I believe, we actually have our college prep workshop series as well. And then here's just kind of a highlight of everything that I'll be working on this year. Here's the research symposium that we're at now. And then I would like to thank the Pennsylvania DEP Environmental Education Grant, because this is a great opportunity for us to expand on this outdoor classroom. Iroquois, Dahl Kempers, and then my lovely team as well. And that's me. Do I have time for questions? Does anyone have any questions?
With the proximity to the Iroquois Library, is there any plan to work with them and maybe combine resources and programs?
That's a great question. We're actually in the works of trying to figure out how we're going to incorporate them into our reading garden, because we had the same idea. They're so close that I'm sure that they would love to be a part of that, and maybe even some of the maintenance, because as you know, with any type of outdoor structure, there has to be a maintenance plan, and there has been interest shown there, so we'd love to work with them. Whoops. Any other questions?
Can you just touch on the angling in the classroom?
Yeah, of course.
Opportunity, because you kind of went through it pretty quickly.
I did, yeah. I was planning on talking about those more, but yeah. So this is like one of our brand new things. This is also, who was the grant from? Fish and Boat Commission. So we wanted to provide an opportunity for students to learn about fishing, especially because of this area that we're from. Obviously, fishing is very important, and that would include things like learning how to bait a hook and learning how to actually fish. And so we want someone who's going to be able to do this year after year, and someone who wants to teach fishing and who loves fishing. But yeah, this is going to begin, our trainings will begin in February, and then obviously we would have to start doing the teaching portion of it towards like the end of the school year. That would be like one of the curriculums for the physical education in schools. Did that answer your question, or? Yeah. Any other questions? All right, thank you.
Get out of here, you can put it on here. Yeah, maybe. The mouth, it like goes really to sleep.
Stay here for a moment while I do this.
Yeah. Actually, You have a couple minutes, you're fine. And I'll introduce you. There's a pointer. There's a pointer on here. You can advance this way or through your presentation. And just pull it up. Here, so I don't lose it. I don't have the time cards for you. We have a 5-minute.
I'm not seeing it come up on here.
This isn't you?
No, it should be the hard drive in here. C should be the hard drive in here. And this should come up as a different letter.
Yeah,
Stick it
try
in.
again.
Hang on a second. I might need to do this.
Maybe it's not happy. There you go.
Thank you.
Sure, I just stood here for moral support.
And then, so I need to launch that. Is this gonna, okay, here's one more thing I need to launch. And then, okay, now for this, is there a way to make this do the
Presenter.
be presenter?
Yep.
Oh, okay.
Yep. So change.
Yeah.
If you're set, I'll be intro. All right, moving right along, we have our next presenter. This is Derek DiMatteo. DiMatteo from Gannon. He's going to be speaking about creating a minor in environmental studies.
Greetings. It's great to be here. Thank you for attending. Looking forward to kind of telling you a little bit about the story of how I've been going about creating this minor. This is a new minor program. So prior to this minor's creation, Gannon offered a program and still offers a program in environmental science and engineering. That program is accessible really only to science students. But environmental issues, as you guys know, intersect with virtually every career field, from law to public health to the culture industries. So creating a minor would fill a gap in Gannon's curricular offerings. There were some challenges that needed to be overcome. It needed to be interdisciplinary, needed to be completable using as many courses from the core curriculum as possible, and it needed to kind of cost no money to establish. So no new faculty or anything like that. So I want to talk a little bit about how I kind of got started with this process. So I'm in the English department, and you may think to yourself, and rightly so, what an unlikely source for an environmental studies minor. But the kind of, the way this started was a little bit windy. And so it began with me looking at our curricular offerings and noticing that we had no environmental literature offerings or courses that would be environmental literature adjacent. And so I started by thematizing an English course, our English 101 course. And you can see here, there. I don't know how to make that go away. But anyways, this is a poster kind of showing the course. The English 101 course is like our freshman writing course. And they were all kind of pretty generic before that. I presented on this last year at the Symposium. The next step was to create another course that went further into environmental literature and culture, film, things like that. And so this course just got created and approved, and I'm teaching it for the first time in the spring. And it's going to be looking at a whole range of different things. We'll be doing some Rachel Carson's Island Spring, Interstellar, The Lorax, Under the Feet of Jesus, Beasts of the Southern Wild, Princess Mononoke, and a bunch of other works. And so let me jump back to our PowerPoint here. So while creating these courses, I started reaching out to other faculty and administrators at Gannon to see what kind of environmental initiatives were already happening, and there were a lot. What I realized was that the only academic program was environmental science and engineering, but that, as I said, it really was only appropriate for science students, and there was no curricular offerings for non-science students. So I thought that was a kind of disservice to most of our student body, and also an opportunity, right? An opportunity for our existing students, but also an opportunity to attract a certain set of prospective students, applicants, right? And to serve a need. So around this time, two other things were happening that I was involved in. One was the CHESS Strategic Planning Committee. CHESS is the College of Humanities, Education, and Social Sciences. And I was on the Strategic Planning Committee, and we were talking about the need for interdisciplinarity across the curriculum. And so it seemed to me like an environmental studies program would fit the bill. Right? And so I kind of took it upon myself to create this. The other thing that was happening in the university is, as a Catholic institution, Pope Francis's encyclical Laudato Si was a topic of conversation. The concept of integral ecology was introduced in Laudato Si as something of importance. And so I kind of just took that and ran with it. As part of the rationale for creating an environmental studies minor. So I just kind of took the initiative and decided to create this minor, and hoped that other people would approve of it. So, which has been the case. Actually, there's been like tremendous support for it. Across the university, so that was thrilling for me to see. So rationale and goals for this, creating academic offerings in environmental studies to complement the university's broader environmental initiatives, of which there are many, too many to list. I wanted to provide a minor that was accessible to non-science students, right? So primarily humanities and social sciences oriented, but also that would reach students in business, and I wanted to create something that was interdisciplinary. And for me, it was really important to get buy-in across the university. I wanted it to be interdisciplinary, and I wanted to build it in a way that meant it would draw on courses from all three colleges. So I wanted to also make sure that the minor could be completed easily. Without taking up a lot of electives, right? Of which certain majors and programs have very few. Like their programs are so cram-packed that the students actually don't have more than like 2 electives. So it makes it really hard to add a minor if you're doing physician assistant, for example, right? And you're interested in community health, and environmental issues are part of that, but it's not part of your coursework as a physician assistant. So how do you add that in? Once you start opening that, it's a real can of worms and very, very challenging to kind of get programs that they can do. So that was the biggest challenge actually. And so looking at the core curriculum, which is the equivalent of gen ed, and trying to figure out where courses could come from, so that if they had to do electives, it would be a very small number of electives. I wanted to make sure that, what part of the justification for this was, right, to get buy-in from the university was this would increase our competitiveness with peer institutions, of which, half of which offer environmental or sustainability programs aimed at non-science majors. They all have science programs for environmentalism, and half have ones that are also aimed at non-science majors. And so I thought we could, by adding that, it would help us. Target audience for the minor, there's internal audience and external audience. And so there are majors that this minor complements, I think, and that is actually the hard sciences and engineering. They benefit from discovering interdisciplinary connections and humanistic approaches to environmental issues instead of only being solely focused on science and engineering, right, without having that bigger picture and the humanistic aspect. And so really it's attempting to appeal to not just the humanities and social sciences, but business, health, and science majors. And they would all benefit from the interdisciplinary training that'll enable them to work in roles that combine fields, right, such as environmental law. So having an understanding of the science and the legal aspects and all of that, I think, is crucial. And then the external audience, there's a potential to attract new applicants, right, to the university. Environmental issues are of great interest to young people, not just people who are interested in science careers. And many non-science career paths intersect with environmentalism, and so students want to see that, law, policy, finance, risk management, health services, public relations, K-12 education, and more. So the process, I began by looking at model programs elsewhere, and I was really inspired by the program at Wisconsin. It formed the primary model on which I based my own minor proposal. And I looked at Gannon's peer institutions. I reached out to faculty across the university to get support for the project and who could serve as sounding boards during the development of the minor. So faculty from biology, chemistry, business management, law, poli-sci, and more. And I began drafting my proposal and solicited periodic feedback. I saved the document on OneDrive, shared it with faculty, and at several stages of development solicited that feedback from them. So the program description is quite long. I don't want to share the whole thing with you because it's very long. But basically, it covers a few kind of like points, right? It talks about what is the environmental studies minor, what is an interdisciplinary approach. It mentions extracurricular opportunities and internships. So just some of those include opportunities and internships around Lake Erie, Presque Isle, Project Neptune, the Goodwill Garden, the Gannon Environmental Club, Regional Science Consortium, Dick Moody Environmental Justice Writing Award, variety of travel programs that Gannon offers, including service learning and field work to places such as Yellowstone National Park, urban farms in Detroit, and a new course that I'm developing that's going through committee right now, which is eco-criticism in US and Japanese cultures. And that course will be a travel course in which students at the end of the semester go to Japan, meet with some counterparts, Japanese students there who they've been collaborating with during the semester, and we visit some locations around Japan, environmental related locations around Japan. So there are, there's a catalog description, obviously, that I will not read, but be quiet and let you skim through real quick. Okay, the next slide kind of explains the structure of the minor, and this is the really interesting part to me. This is I think the most interesting part of the whole presentation. So, yay! Happy slide. This is the best slide. Okay, so you can kind of see that there are two required courses. One's in environmental science, the other's in environmental ethics. So those are two required courses that come from the core curriculum. So they don't require elective slots. Yes. Then they need to take one more course from each of these three dimensions over here, okay? And so the total is 5 courses to get the minor. So 2 of them are already in the core curriculum, so no electives needed. The others, some of them also come from the core. So potentially, the minor could be achieved with only one elective slot or maybe 2 elective slots, right? Which makes it really accessible to a huge number of students within the university. This is the best part of the whole thing, I think. So I'm like pretty excited about that. So the basic idea is you can kind of like go through and I'm not going to go through this whole thing, but we have a whole bunch of different courses from all across the curriculum in these different perspectives areas. And so you can kind of see a variety of these different courses, science courses, and policy and decision-making courses as well, coming from a range of different disciplines. And so, and more are going to be added, actually. There are some programs outcomes for the students related to these 4 things. And the minor is going to basically be administered in this way. There'll be a director, and there'll be an advisory board with 1 person from each of the colleges. I think there are some benefits. We might have a slight increase in enrollments in the courses that are part of the minor. Student demand for new courses that could fit the minor might mean that more new courses are created in environmental studies, which is a good thing. And faculty opportunities for cross-disciplinary collaboration increase. Job applicants can be positively influenced, so we might attract more faculty who might not otherwise want to come to Gannon. Then also prospective student interest might increase, which would also be a good thing. I don't know if you're aware that there's a decline in demographics of college-going peoples. And so all of the colleges in the area are faced with what will probably be a pretty steep drop-off in the number of college-bound students in the next 5 years. So it's kind of going to be there may result in mergers or closures. Anyway, the larger macro environment is not good. But I think that this sets up potential for growth, right? It could, from a minor, it could grow into a major or it's a program in its own right. I think that it enables more collaborative potential, which hopefully will dovetail with other initiatives that include RSC. I think that maybe if that growth is large enough, there could be something like an interdisciplinary center for integral ecology and sustainability that comes out of Gannon. I don't know, right? I think that would be pretty cool. And that is it. So if you have ideas, feedback, things you want to collaborate on, please get in touch with me. Let me know. Would love to hear from you. That's my last slide. Yes.
Does Gannon already have all those elective courses, or do you have to develop them like that? Those 3 lists of multiple elective courses.
So those lists are all currently existing courses, and then there are a few others that are in the pipeline. One of which is an environmental justice course that is being created by Dr. Chris Magno. I don't know if any of you have seen him around. He also does the GIS courses at Gannon. Yes.
Yeah, Derek, thanks for your presentation. Greg Andreso from Gannon. I don't know if we've ever met, but not to air too much kind of Gannon, getting into the weeds, but that nine credits have to be unique to the minor, right? You can't count elsewhere, like in your major or in the core. That came on board about a year ago, so I guess it would be three of those courses would not be able to count for part of your major.
Right. Yeah.
So that kind of changes that landscape a little bit, depending on what your major is, I guess.
Right. Yeah. I think is not necessarily a bad thing for an interdisciplinary minor to have students need to go outside their major I mean, that's part of like the whole point of the way that this one is constructed. So it makes it a little bit more challenging, but also like is part of the point, I think. All right, thank you guys very much. Really appreciate it.
It's not ticking yet. I'll let you know.
I'm calling the Rangers right now.
Your mine has to be in nested folder in itself.
Yeah, I just dropped your folder onto the desktop when I dropped him out, so hopefully it opens. It doesn't seem like it wants to. Is this all you?
What's up there? It's over there.
Well, I don't know how to fix that. But I can't see it here.
Can we scroll to the other screen? I've got it. It's okay. It's good.
Park manager, not
It does
IT.
that.
Not at all. Hold on. All right. I believe this is our final talk for this session. This is David Horn from Gannett University once again, and he's going to be speaking on the April 8th, 2024 solar eclipse, if you might have heard about it. Nationwide research and Erie community engagement efforts in the shadow of the moon.
So we're going to keep the Gannon train rolling, as we just said. I corrupted the Gannon logo down here on the left side of the screen, so it has an eclipse on it. I've been doing that all over the place. It is surprising how many people do not know that there is an eclipse coming on April 8th of next year. I've been working on this nearly for almost the last 2 years, so I'll be grateful in some ways to see the end of the eclipse. See if this movie actually plays in here. No, it's not playing itself. That's not a problem. I will talk through it anyway and do this through the medium of dance. So the great thing about our solar system, and let me just sort of come through here, is that the moon in the sky is actually about the same size as the sun, just angular. Obviously, they're very different in physical size, but our moon fits perfectly over the sun, and that's a really nice coincidence. And that means on specific occasions, which this movie should be showing you, the moon, when it's in the right position with respect to the Earth's orbit, will actually go completely over the sun during the day and give you your total solar eclipse. There are other types of eclipse. I'll mention those shortly here. But the total solar eclipse is the most spectacular one that people really want to see. Unfortunately, because of the way the eclipses work, the actual shadow from the moon is actually quite small. Let's see if I can actually make this thing play. No, it's not going to do it. Oh, so in terms of the actual shadow, it's only a few miles across, which means you have to be in a very specific place to actually see the total eclipse. Other places, quite a lot of places, see a reduction in the temperature here and reductions in wind speed, humidity. Not a lot of response from the pressure sensor, unfortunately, which is rather surprising. But you can definitely see a correlation here with all of the other categories, which is rather nice. I've zoomed in on it a little bit more so you can see those in a bit more detail. We are capable of also looking at the wind direction as well. Didn't see much of a wind direction shift in either case from either site. In Erie, I actually did get one spike of about 15 meters per second as a gust as well, so it wasn't the greatest day for it. But you can see the wind directions there, pretty much consistent throughout the day. One of the things I am looking to do, and this is a shameless plug from me, is I have people who are somewhat interested in taking one of these anemometers and running them for me, but I'd really like people to sign on the dotted line who are actually under the totality across the nation. What would you have to do if you want to be involved in this study? Well, you get an anemometer in the mail. I'll send it to you free of charge. Be on the line of totality is one of the things you have to do. I definitely want people on totality. Point the unit north. You have to switch it on using the on switch. You can figure out the rest of the controls for yourself because it has an off switch as well. So switch it on, switch it off, put it back in the box and send it back to me. And you get the data reduced. And anybody who's participating will get an acknowledgement for being part of the project. So I do have people who are somewhat verbally promising to take some of these units, but I really want people to sit down and take them. So I've got units going to Missouri, obviously the Erie one, but I would really like to find people who are more interested in really confirming with me that they would like to take these sites. So if anybody knows anyone anywhere from Texas, all across the nation basically, or in Maine or Canada, I'd like to put one of these further north if I can, please let me know, or put me in contact with whoever might be interested. So that's the research we're conducting. Our outreach is pretty extensive as well. We do know that when eclipses occur, people do want to go and see them. Here's the 2017 solar eclipse that I saw from Missouri here. We have a pretty extensive website with lots and lots of information on it if you wish to go to it. And if you take a pair of these glasses, the QR code on there will take you straight to those videos and all of the things that we're offering. I have been absolutely blitzing anything I can in national, international media, shameless, egocentric plug there, to talk about the eclipse. Partially because we really want to distribute a lot of these glasses to as many people as we can. I am involved with IU5 and other institutions, Penn State, other places, to try and make sure that all the students in the Tri-County area actually are getting a pair of glasses each. Gannon specific, we are building eclipse windows. These will be large solar filters that people can observe through. We'll also, on the day, be conducting telescope viewings. There'll be at least one place for the Gannon community to go, which will be our football field, and then we will have a couple of other locations, one on a sort of friendship common there by the Chick-fil-A, and we're also working with the Downtown Partnership to put something into Perry Square as well. So if anyone's interested in any of that, please follow our website, feel free to see us. There's lots of information on the site, as I said, and there we have, there's Tom Ridge Centre mentioned there, 343, your extra second of totality. So we will be doing a broadcast on the day, giving people timing and accurate information, but anything you need in terms of outreach, or even if you're curious about the research we're doing, please let us know or follow us from our website.
Did you mention which day of the week?
It's a Monday.
Monday?
Yeah. Oh, no, there he goes. Yeah, I'll get to you.
I was looking at your data there. It looked like during the annularity, there was a lot less variation in some of those.
Yes, the noise seems to calm down.
Yeah.
I noticed that. The data's pretty noisy. And then it actually settles down a lot, especially if you look at the humidity. I did not expect such a change in the humidity. I mean, it's not an enormous change, but the change is definitely there during the annular. And you know, the annularity that I put in there, I mean, it's a lot of the sun is getting covered before and after that as well. But you can almost see a bite taken out of it there. It was rather surprising, yeah. It may be something to do with the response of the sensors, maybe more so than the actual environmental fluctuations, is my guess. We've got some testing to do.
Mine is more of an ask. My students are already asking, could we cancel classes? Would you be able to convince administration?
I tried desperately to tell them to cancel the classes, and they said they didn't want to do that, and it's optional for the professors to give people their time or not. I obviously am going to be so busy on Monday, I'll tell you that I'm cancelling classes on that Monday because I've got things to do. But yes, I have made some attempts to make that happen. Yeah. Pressure people. Yeah. Anybody on the totality?
Any?
Yep. Further south the better. I can probably cover the sort of middle, sort of Midwestern states, okay? Towards Texas, Oklahoma would be nice. Somebody up in Maine or Canada would also be quite good. But just, even if it's someone who's traveling to the totality, what I'm really looking for is just reliable people who are going to actually follow through, even if they're traveling to it.
So does it have to be like open setting, or could it be like urban, let's say the backyard, for example?
As long as it's exposed to essentially exposed to the sun, it's absolutely fine. I'd say you probably want an exclusion around it about 6 feet or something, so you're not getting in the way of the sensors. But as long as the sun's at quite a high altitude, so it shouldn't be too difficult to actually make sure it's exposed to the sun. Thank you.
We now have time for a break, and then the next session starts here at 4:20, so help yourself. Take snacks, drinks in the back.
Yo. Yo.
like to introduce Varun Kasarini from Gannon University. Varun?
Hello. Hello everyone, good afternoon. I'm Varun Kasarini. I'm an associate professor in environmental science and engineering. I'm going to present about a research project that we've been working on since 2019, technically. But now we have the final data set to present. It's about urban litter and plastic pollution. Most of you or all of you have seen some pictures like these, like fish, seals, or turtles wrapped up in nets, plastic things, and maybe something like this, microplastics in fish, zooplankton, etc. So there is an estimate that 10,000 tons of debris end up in Great Lakes every year. That's an estimate based on several assumptions, waste management practices, etc. But there is no concrete data on like, how much exactly goes in from a certain area, like a city or different land uses, etc. Right? But most researchers in their publications, when they publish about pollution, marine debris in Great Lakes or oceans anywhere, they do mention litter is one of the primary contributors, urban litter that happens on our roads everywhere. That's a primary contributor, but no one actually quantified it, like what is it that's going in, how much. So just quickly, some pictures. All the litter, when it rains or when there is a snow melt, that slowly gets into our stormwater infrastructure, which takes all that into Lake Erie or Great Lakes or other water bodies. During that process, some of those macroplastics, bottles for example, could break down into smaller pieces that ends up in fish, etc. But there are also microplastics on the surface, on roads that are coming from cars, or if there is an accident, for example, a lot of things break, right? Those things could end up in micro level. So those things also directly end up in water bodies, resulting in all the things that impacts marine life and water quality issues. So for our research, we looked at what's the urban litter contribution to plastic pollution in Lake Erie specifically, but that could be extrapolated to Great Lakes. We also wanted to know what are the factors that are contributing to these different levels in a city, for example. So we looked at seasonality, like fall, summer, spring. We couldn't do winter sampling. And then rainfall intensity, is there a correlation if it's heavy rain versus light rain? Drainage area and land use, if it's an industrial location versus a commercial, residential location, and also within residential location, income levels, the socioeconomic factors, are they contributing to the amount of litter that we see? So City of Erie, Gannon being in city, that's one of the primary reasons we chose City of Erie as a research location, but also it's a very good representation of a lot of cities around Great Lakes and Rust Belt. It has a really good distribution of residential, industrial, and commercial areas. This is a map generated by our grad student. I think roughly about somewhere around 18-20% of commercial, 18-20% of industrial, the rest residential. That includes parks and all that. This is a map from Erie County, 2019 census, like different income levels also. Like within a small area, you can see really low income to high income relative to the city. Okay, so we chose several sampling locations, 2 industrial locations, 2 commercial locations, and 3 residential. Each residential location, one is in middle income, high income, and low income areas. So if you're familiar with Erie, these are all the sampling locations. Just pictures of where exactly we sampled, the drainage locations that are there. So just different drainage areas and like pervious, impervious cover in these locations. As you can see, each location has different drainage areas ranging from 0.5 to 1.5 acres. That's the drainage area designed for that one single drain we sampled in. And there are different levels of green open spaces depending on where we sampled. Okay, so this is one of the things that we had to do for almost a year, and right after we began this project, COVID came along and things got complicated. But research so far into stormwater looked at dissolved pollutants and suspended solids like sand, soil, all that. But no one actually, when we started it, published anything about microplastics sampling for stormwater. After, in the last 3 years, there were some publications outside US from Europe and Australia that came out. So we had to innovate what would be the best way to sample for microplastics and litter. So we tried different things, but after a lot of work and working with the City of Erie Sewer Authority, we came up with these strainers because our city drains, if you ever get a chance to look at it in the city, you can see the history going back 100+ years. And we had to be a little creative with the shape of the strainers and all that. And luckily we found that there is a company right, I think somewhere between 12th and 15th Street, somewhere there, Erie Metal Baskets. Their actual specialty is to make something like these. I was looking online how to get these made, but yeah, luckily we found one right in the backyard. So we deployed these strainers for during a storm event, looking at the forecast 24 hours before it, because we couldn't go right before the event. We need City Sewer Authority people to be there when we deploy these. We left the strainers there during a storm event. We collected them back within 24 to 48 hours, depending on their availability. These are the 8 events we looked at the data for. We did sample more than that when we were experimenting with the strainers and all. You can see different rainfall going from really light rain, 0.14 inches, total rainfall to 1.29 is the highest. And we categorize the rain based on how much rain we get per hour, the intensity of it. So it's a light rain, it's about less than 0.1 inches per hour. Most of the rainfall that we see in Erie is light to moderate. Once in a while we get heavy rain. Well, I've been in Erie 7 years, I don't, maybe I've seen a violent rain even once or twice. And then there are different seasonal sampling here. We did summer versus spring, fall. Winter, we couldn't deploy the strainers because of snow shoveling. The city don't want us to have anything in the drains at that time, so we couldn't sample it during winter, snow melt and all. Okay, so once the samples are collected, we brought those strainers to the lab. This is another thing we had to do because at that time, because of COVID, we were not sure what was going to be in our sample. There was a lot of PPE being thrown out on the roads. So we had to let the strainers sit ideally for 5 days. That's we found it, some microbiologists recommended that's the best way. So we let it sit for 5 days. After that, we scraped everything, put it in big baking trays, air dried, and then we sieved it. So anything macro, anything greater than 5 millimeters, got picked up by hand. You can see, I don't know in this image if it's clear enough, but a lot of cigarette butts, as expected. Anything, large bottles, large pieces of paper, plastic, fabric, anything, we removed it by hand. The rest of the sample was sieved through a 5 millimeter and a bottom sieve of 300 microns. So that's the most common accepted microplastics range. So the sample was collected. We got typically about 3 to 4 pounds, depending on the rain event and the location. That's how much sample was collected, and we couldn't process the entire thing, so we had to take a subsample of it. Processing just one bowl of it will take a lot of resources. So that went through some oxidation to digest any leaves, grass, or any other organic matter that could be digested. Then we had to apply a series of density separations using different solutions to get rid of things that we are not looking for. So for example, tire pieces, which in a future project I would be interested in, but it was difficult to get rid of them. There's still some partially decomposed organic matter, grass, and all. So we had to implement a series of density separations to get to our final plastics. Then even after that, we found some leftover material. So, well, I didn't do a lot of that. My students, they looked under microscope. They were picking up non-plastic materials. And then after that, those samples recently, we did FTIR to identify what type of plastics are those pieces. We also, there is a step that I skipped here to make sure what we are looking are plastics. Even before this, we went through a process of dyeing those plastics with Nile red and using a fluorescent light to see if those are plastics or not. Okay, so getting to the results part. So macro litter, this is data from all those locations and all the different events. And we normalized this data. This data is normalized to ½ acre of drainage area, as I pointed out in the beginning. Each location has different drainage area, so that means it brings in different volume of water. So we wanted to normalize to ½ acre of drainage area. So from here we can see commercial locations and low-income locations. These three had significantly higher amount of litter compared to other locations, industrial and middle and high-income locations. So just in the form of numbers, the same data normalized. As you can see, low-income commercial locations has higher amounts compared to the others. We did some statistical analysis on this. Okay, all right. So what's in that litter? This is a combination of all the locations, all data sets. So 30% of it is smoking related. So that includes cigarette butts and anything related to smoking, vaping devices or anything that we thought were smoking related went into that category. So 30% of all the macro litter that we collected is smoking related, and 28.5% are plastics. This is separate from any plastic related to smoking. These are just like bottles or straws, things like that. Toys, sometimes we found a lot of those. And paper and a lot of other things. We categorized everything. I even have data, I'm not showing that here, but for each location, there is some difference. Like, so for example, industrial locations, we found a lot more cigarette-related materials. Made sense. Commercial locations, we found a little more plastic-based. Right, macroplastic. So now with the macro litter, we separated anything plastics from all the macro litter. When we look at that, similar trend, commercial locations, Peach, Parade, and German, this is the low-income location. They have significantly higher amounts of plastics, macroplastics. Same data, just showing that low-income and commercial locations have more macroplastics. No difference between the other three types of locations. Microplastics. So this here, the trend is somewhat different. Still, commercial locations do have higher amounts, but industrial locations, so Haybarger and West 20th, this is where, can't remember what the exact plastic industry is, but there is a plastic industry right where we are sampling. So we found a lot of pellets Could be while they're transporting them, or we couldn't figure out what the exact reason they're there, but definitely mishandling of material. So industrial locations did have a lot more microplastics. Another reason could be meaning any plastic or anything that gets thrown on the road will get crushed more often than on a regular road where it's more car traffic. So it's difference in load and the amount of wear and tear these things are going through. So we found more microplastics in industrial and commercial locations. Okay, it made sense because of the traffic and the types of materials that are being thrown. So that's, industrial and commercial locations have the highest average microplastic count compared to residential locations. Right. So identification, when we look at the types of plastics, as you can see, we collected hundreds, thousands of microplastics in our samples. We couldn't analyze all of those. This is from, I think we analyzed about 600 pieces of microplastics in total, identifying them. So on an average, forgot like 35.5% are polystyrene. These are from like insulation, cups, egg cartons, etc. that easily gets broken into pieces. And then next highest, pretty close, polypropylene and polyethylene. Packaging, garbage bags, all that, and then yogurt bottles, etc. Okay, things that we usually see people throw on roads and surfaces. The rest are all smaller amounts, but from different applications. Some could be from cars, electronics, ABS plastic could be from electronics, or 3D printing. We did, in some samples, we saw a lot of toys repeatedly. Beads, we found once beads show up in multiple samples at the same location. We got chicken wings, lot of stuff. Some days I felt bad for our students that were doing all this. Okay, so taking all this data from the city of Erie, from different locations, if we use this data to estimate how much microplastics are going into our litter is contributing to marine pollution, taking half-inch rain event and average concentration. So if we use average concentrations of macro litter, macroplastics and microplastics, these are the amounts. So 300,000 on an average. That's how many pieces of macro litter will end up in Lake Erie for half-inch of rain. That's just from city of Erie. We're not talking about entire Pennsylvania part of Lake Erie. And so microplastics is something I would like to point out. Like, if we take the lowest number that we found and use that to estimate, we're looking at 1.5 million pieces for half-inch of rain. Now, we typically get anywhere between 40 to 50 inches of precipitation in a year. So if we use that, I'm using 40 inches, the lower end of it. 120 million pieces, that's a conservative estimate from city of Erie. And this is just microplastics directly going from the road surface. There are also macroplastics. Now this, some 6 million, or like even the lower end, 760,000. Those things can get broken up into billions and billions of microplastics. So in conclusion, income levels do have an influence on the amount of litter and microplastics that could end up in Great Lakes. Land use has an effect, industrial versus commercial or residential, there is an impact on that. Season, we did see fall samples had significantly lower amounts of litter, macro litter, but spring and summer samples do have higher amounts of microplastics, which made sense. So in spring, when the snow melts, you can see on highways and road surfaces, there's a lot of litter accumulated. So those things break during spring. Also with summer, a lot of foot traffic, people are outside, so they throw stuff. a lot of car traffic, so that resulted in higher amounts of microplastic. So that's the data present. There's a lot more data I'm not showing here. My research partner, Dr. Mason from Barron, these are the students that worked on our research, and City of Erie Sewer Authority helped with all the sampling. And this research is funded by Pennsylvania Sea Grant, so thanks to all of them. Some of the references. Thanks for your attention. And
We're going to move on to the next presentation,
Okay.
but Varun's going to stay, so if you have questions for him.
cannot,
Oh,
sorry.
no.
Sorry.
Sorry, I tried to.
Actually.
But
Actually. But you can find me, email me.
Thank you, Varun. Okay. Our next presenter is Lynn Beatty from Penn State Erie. You know how that works.
Hello. Good afternoon. So as Jeanette said, I'm Lynn Beatty. I'm at Penn State Barron, and this is our annual update on the work we do on invasive snails on Presque Isle. And this is, of course, done with a lot of help. My three other PI co-authors are Adam Simpson, Sam Newtile, all from Penn State Barron. So we all know aquatic invasive species pose threats to the integrity of biodiversity, especially in aquatic ecosystems, freshwater ecosystems. And one group of invasive species that receives relatively little attention are snails. And that's primarily because, number one, they're hard to identify. Most people don't know what's native or what's invasive in their own community. Plus, many of them are small, not these ones, but many of them are very small, so that most people don't even notice that they're there. Plus, a lot of their effects are also not super overt. So the snails that we work on are called mystery snails. So they're called mystery snails because they are ovoviviparous, so they give birth to live crawling young. So the idea is you have one snail in the tank one day, next day you have a whole bunch of snails. It's a mystery how they got there. That's what I've been told is the origin to that, although I'm sure there are other stories as well. So these guys are large snails, in case you can't tell from that scale bar. Adults are usually the 3-inch range. They're usually pretty globose, although we do have a couple of species around that vary in body shape. These guys are found on Presque Isle, in case you can't tell, and a number of other places in western Pennsylvania. So they're originally from Asia. Both of the species that we have here are originally from Asia. They were originally brought to the U.S. in the late 1800s on the west coast, California, for food markets. So they were originally brought in for food for human consumption. And we have had people on Presque Isle ask if they could have them take them home and eat them. So of course we have to say, no, don't do that. That's a terrible idea. But they were moved to this side of the country in 1940s-ish. They were introduced into this area primarily as food for channel catfish. They were first introduced first reported on Presque Isle in 2006, but anecdotally talking to some of the people who have lived in the houseboats, they've been here for much longer than that. So there are people in the houseboats that claim they saw them there when they were growing up in the 70s or so. So it's likely that they were there much longer. So why should you be worried about mystery snails? Well, there's a couple of reasons. One is that they have negative impacts on a number of native species. So that includes native snails, and we don't have a good database of what native snails were around first to even know what the difference is once they've invaded, which is problematic. There's also some recent work showing that they impact other species as well. So this paper came out in January on functional ecology that showed that the presence of mystery snails, especially when you combine it with other species like goldfish, which we also have on Presque Isle, can cause declines in a number of herbivore populations. So they did find an independent effect of mystery snails on growth rates and I think metamorphic rates of gray tree frog tadpoles, but when you combine them with goldfish, there was a number of other effects. So they affect more than just native snail species. We know also that all trematode parasites, so all of your flukes, have to go through a snail as an intermediate host at some point. These guys are massive. Remember, they're 3 inches big. 3 inches big. 3 inches long from spire to the tip of the aperture, so likely they can harvest. It's late in the day, sorry guys. They can harbor a lot of parasites, but we don't know what they have at this point in time, so we don't know if they brought parasites with them from their invasive range. We're not really sure what they're doing to host parasite dynamics, even with just native parasites. We also have evidence that they accumulate a lot of contaminants. So these species are actually used as bioremediators in certain parts of their native range because they're so good at picking up and holding on to contaminants. And we have evidence from our group that shows they hold on to a lot of metals, especially in their shells and soft tissues, which isn't good if something eats them. But the first step, of course, in figuring out what kind of impacts these snails might be having on Presque Isle in particular is to figure out how many there are. Because you can't really speculate as to what the impacts might be until you figure out how many snails are there. So that's what we sought to do. We started last summer and then we picked it back up and did a lot more robust estimates this summer. So we aim to generate population size estimates for Presque Isle on the whole, and there are distinct little sub-pocket populations in the park, and we wanted to figure out where some of the more abundant subpopulations are. So we focused in on 4 locations in Presque Isle State Park: Feather Platform, also known as Leo's Landing, kind of close to the entrance, the Vista 3 boat launch, if you're familiar. Lily Pond, which is the little pond right by the ranger station. Graveyard Pond, which is where you launch boats to go into the lagoons. And then Thompson Bay up top there. So we focused on those 4 because that's where we had detected those snails in the past. We knew that they were fairly abundant. It seemed like good places to get estimates for. So at each of those locations, we set up a number of transects. So the number of transects present in each location depended on the general size or shoreline of the area, plus general accessibility. So here, for example, is what we had at Feather Platform. We had 5 different transects along the side. We don't have any over there or over here in this corner, primarily because that's like all brush, and no thank you. I don't want water in my waders immediately. This area over here is also quite mucky and can get dry, so it's just generally difficult terrain to navigate. So there's our transects for Lily Pond. We had 7. Again, we didn't put any over here because this is Mosquito Alley. So if you go over there, you're probably going to get West Nile. Just kidding. Thompson Bay, we had 15. It's a much bigger site, so we have 15 transects throughout that area. In Graveyard Pond, we had 5 along the side, again, mostly due to accessibility reasons. So each of these transects, 1 by 10 meters. We did have 1 meter square at each end that we're searching for faucet snails, a different snail. We did not have enough recaptures of those for me to present that result here today, so we'll just focus on this 1 by 10. These were searches where we had a whole team of students come back for 4 days in a row, searching the same exact transects, and we did this 3 times throughout the summer. So it was 4 days in a row, 3 times, for a total of 12 days, essentially. On each of the 12 days, every snail that we found was collected and tagged. So we tagged the snails with B tags. So there are tags that they use to mark queens. There's these circles here that are different colors with numbers. I realize the outside of this picture is blurry. Snails are moving really fast. There's only so much you can do. But anyway, different colors, different numbers, and we used UV setting glue, which if you ever have to tag anything, I would recommend. UV setting glue, super fast. The only time we had trouble with it was in the rain, which I'm sure you can imagine why that was a problem. So we tagged a bunch of snails. We also found some of the snails that we had tagged last year. So last year we ended up using a series of paints to mark individuals because we ran out of numbers so fast. So you can see what the original paint marks look like here. Here's an individual that still has its 4 paint marks. You can also see growth, right? So every snail was marked on the underside of the body whorl. Last year, it made it all the way around. That's a lot of growth in just 1 year. Not everyone had the same amount of growth, but this particular individual that I happen to have in the picture does. So we tagged a lot of snails, so much so that we ran out of uniquely colored B tags and had to add a dot of UV setting nail polish, which also worked, by the way, for a color code on it. So this individual, for example, is white red 23. And we ended up tagging in total in functionally 11 days. So on the last day, we collected everyone. But in those 11 days, we tagged a little over 1,400 snails. So quite a few there. So we took that individual mark recapture history data, put it into some Jolly Zebra models, and we get population estimates. So here I have the estimate for Feather Platform. We ended up with about 1,500 snails or so there. And you can see this number is the average. Those are 95% confidence intervals. At Lily Pond, around 423 or so. Pretty confident in that number, by the way. It's pretty tight. Thompson Bay, you can see quite a few more snails over there. Graveyard, not so much. So all in all, we put these together. We end up with an estimate in those 4 areas of a little under 7,000 snails, give or take, which is quite a few snails, considering we're talking about things that are this big. So I want to point out Graveyard Pond, because that's a little bit lower than it has been in the past. And we recently, really since water levels started to drop, we started finding fewer snails in Graveyard Pond. It's kind of like a trade-off, or I don't really know how to explain it, but we always stop at the bridge too. We always stop when we sample at the bridge between Marina Bay and the lagoons, because that's where we survey for faucet snails. And last year, for those of you that were here last year, we found a mystery snail there for the first time. And we claimed that it was people moving it and dropping it off there, and everyone was like, yeah, that's it. Guess what? Found one there this year. We're like, okay, we're gonna tag it, we're gonna see what happens. Found it again, cool. Then we found more, we found more. And then we found some more. So they are in the lagoons. Mystery snails are in the lagoons. We hadn't observed them before. I don't know if it's a change in water level thing and we just didn't detect them, or if it is in fact snails moving in either from this way, from the Graveyard Pond way, given that we saw that kind of decrease in detection in that area, into the lagoons, or if they're coming in from elsewhere. So we do have snails collected, hoping to do some population genetics so we can figure out how are they getting in there. But the population seems robust. Anecdotally, the snails that we usually find in Graveyard Pond are smaller and tend to have thinner shells than some of the other locations in the park, and these ones are pretty robust. So I'm not quite sure what that means, but anyway, we're going to do more mark recapture there, or at least initiate mark recapture there next year so we could try to figure out what's happening over in that area. We also had one oddity, Red 75. So the story of Red 75 begins in June. June 26th, this snail was tagged in Lily Pond. You want to guess where we found Red 76? Thompson Bay. Thompson Bay in August. So options are, that's a really fast snail, number 1. Option 2, a critter moved it. But again, we're talking about things that are pretty big, plus you need to have a critter that's going to be able to carry it from there to there. I don't want to get any like Monty Python level discussions here about whether or not they can carry the weight of a snail. I mean, it's possible, okay. But we're thinking that it's probably human movement. Taking a snail, being like, oh shoot, this is alive, huck it into the pond, not realizing that it was still alive or something like that. So next year, as we continue to do more mark recapture, we again will know where we tag them, where we're seeing them. Maybe there'll be even patterns of, let's just say, facilitated movement around the park. Plus, it'll augment our estimates. Maybe we might be able to see a change in estimates across years. We're also going to do some genetic work, again, trying to figure out where those lagoon ones came from and just where in general these guys came from, how they might be related to mystery snail populations elsewhere, since we do have a lot of samples from all over the state at this point. We're also going to affix some pit tags on some snails to look at movement. So we can hopefully rule out that it wasn't a snail moving all the way across Presque in a matter of 8 weeks or so. So look out for those guys. So with that, I'd like to thank our funding sources, Penn State Barron, who supported a number of our students over the year, Pennsylvania Sea Grant, who funded this research, a whole army of undergraduates that have helped across the years, Regional Science Consortium for letting us present here today. And with that, I'll leave you with our 2000s boy band field picture, and I'll take any questions.
Okay.
I
possible for the snails to move on boats or kayaks or any of that kind of?
Maybe they can hold on pretty tight. They generally don't like a lot of wave action, so I think there is a limit. So maybe like a motorized vessel, probably unlikely unless they're inside somewhere. So if they're inside shelter and then get emptied, that could definitely be an option.
Is dragon aquatic plants?
Yeah, it could be if it was tucked in.
The other question I had is just like, it seems like most of the areas you know about are like on the edges of Presque Isle, and then you mentioned the lagoons. So are you thinking that the ponds on the interior are mostly snail-free or mystery snail-free? And do you want sightings if we're out there and we see them? Do you want to know about?
Yeah, I would love to know. We haven't seen them in the waterworks ponds, so as far as I know, they haven't been reported there. But yes, I would love for people to tell me when they're elsewhere, especially if you see tagged ones. You can always let me know when you see a tagged ones. You're gonna see them. Yeah.
Are you working on any like educational materials or like posters so like the public knows not to like spread them other places or like just information like about them?
We have some stuff made, and we have started drafting educational materials for schools. So two of the Snail Squad are here, and they drafted stuff for me this summer that I have not had a chance to look at yet. But yes, we're working on it. We're also working on a website too. Yeah.
Thank you very much.
Yep.
We're a little bit ahead of schedule, so we're just gonna take about 2.5-minute break. We'll go ahead with our next talk. So Haley Altadonna from Penn State Erie.
All right.
So I'm an undergraduate at Barron right now. I'm going to be talking about some work I did last summer, looking at transgenerational responses to predation risk in snails. So I think we all can kind of imagine that predators have a number of ways that they can influence their prey. I think the way that we most commonly think of is through what we call consumptive effects, where the predators consume the prey and directly reduce the population size. But predators can also have a number of non-consumptive effects on the prey as well. So just by being in the environment with the prey, if the prey senses the threat of predation, they can induce behavioral or morphological defenses to kind of cope with that stressor. And what I just described is kind of known as within generation plasticity. So they can alter their phenotype to be more favorable to cope with that predation stressor. It can get a little bit more complicated though when that snail goes on to reproduce and they have offspring. The offspring can also induce behavioral or morphological defenses based on the information they receive from their parent. And that is known as transgenerational plasticity. So this can kind of help the offspring cope with these stressors and hopefully have a more fighting chance against the predators in the environment with them. And this is particularly significant and interesting to look at with snails because some species of snails are simultaneous hermaphrodites. So they're capable of outcrossing, so just typical mating, or self-fertilization, selfing. So we know that with snails who are reproduced via outcrossing, there is a genetic advantage to that called heterosis. So this is just an increased fitness in relation to their parents and to other offspring that could be produced by selfing. Whereas we see with selfed offspring, we see that they have a kind of inbreeding depression, so they are less fit than their parents or their counterparts that would have been produced by outcrossing. But this is kind of interesting from an epigenetic perspective because we see that snails that are produced by outcrossing are receiving two sources of information, where selfers are receiving one source of information from their parent. So if an outcross snail is receiving two sources of contradictory information, it can be kind of difficult for them to consolidate that information in a way that's favorable for their fight against the predator or any other stressor that might be present in the environment. So it's kind of unknown how, if they are consolidating these information, how they might be able to respond to these predators, if they're able to consolidate the information better than the self-produced offspring, or if they are having less luck doing that. So with that, our objective of our study was to determine how transgenerational epigenetic effects of predation risk are influenced by the reproductive strategies of selfing and outcrossing. So in order to do this, we collected some snails from the genus Physa. These are just freshwater snails, and they are simultaneous hermaphrodites. So we collected 120 of them from 4 Mile Creek on Penn State's campus, which is indicated by that red pin on the map there. And we brought them back to the lab, and those snails that we collected served as our F0 generation for this experiment. So we put them all into a tank together to mate. We gave them 5 days to mate with each other, and then we removed the adults, and by that time they had laid a lot of egg masses in the tank. We let those eggs hatch and develop for 2 weeks. And then at that point we had little baby snails, which were our F1 generation for this experiment. So after they had developed for those 2 weeks, like I said, we put them into individual cups, randomly selected them, and we began applying predation treatments. So we had one group, half of our snails received control treatment, which was just water, and then the other half received predator Q, which we made by feeding snails to crayfish, taking the water from that enclosure, and then also crushing physid snails in some water and combining that with the water from the crayfish enclosure. And this is pretty scary to snails because they can smell the conspecifics being consumed by the crayfish. So we did these treatments, the predation treatments, for about 4 weeks, and we reapplied them 3 times a week. And then we stopped applying the predation treatment so that we could move on to reproductive treatments. And the reason why we stopped applying the predation treatment, we did not want the eggs to be exposed to the predation treatment. So for our reproductive treatments, we had 2 groups of snails that were isolated from a mate for the duration of the experiment. So we had snails in control conditions and snails in predator Q conditions that were isolated from a mate. And then we also had 4 different combinations of outcross snails. So a maternal control and paternal control, maternal predator, paternal predator, maternal control and paternal predator, and maternal predator and paternal control. So we had all of these combinations. And ultimately, we every day would check the cups that we had them in for egg masses after they had gone through with their mating enclosures. And we looked at the egg masses for our reproductive data. So we counted the number of egg masses that each snail laid, and we counted the number of eggs that was in each egg mass. And then we also counted the number of blank eggs, which is kind of represented by this graphic here. This is just the number of eggs that didn't have a yolk, so they would be seen as non-viable. And then we also, once we were done collecting the reproductive data, we also took photos of the F1 generation so we could quantify their shell shape and size, because snails are known to kind of narrow their aperture in response to predation by crayfish. So we wanted to see if we could have an observable effect of that. And so then we moved on to the F2 data. At the point when we were collecting the egg masses and looking at them, we separated them into 6 different enclosures based on the parental treatment. So we let those hatch and develop for a few weeks, and we ended up with 6 different lineages, like I said. We took 20 from each parental lineage, and we put them into their own individual cups in just plain control conditions, and we raised them. And once they were 6 weeks post-hatch, we used them for some data collection to see if we could observe any responses to predation. So first, we did a behavioral assay, looking to see if they exhibit any kind of anti-predator behavior. In this circumstance, we would apply a predator cue, the same cue that I was talking about earlier, and we would monitor their movement in the water. So if they were exhibiting anti-predator behavior, we would expect them to move up in the water column towards the water line. The idea is they're trying to get away from the predator. And then we also took photos of their shells. And again, like I mentioned, we would expect that they would have a more narrow aperture in response to the predation by these crayfish. So let's move on to our results here. I'm going to start with the results from our F1 generation. So on the left, I have a figure on the y-axis is the number of egg masses that were produced by the parental, the F1 generation. And on the x-axis is the days since we began egg counting. So the colors of the lines represent the treatment of the parent. So the red is control treated and blue is predator treated. And we found that snails that were predator treated reproduced sooner than control snails. But overall, they produced less egg masses, which is kind of interesting. And then on the right, I have a figure on the y-axis is the number of blank eggs produced. So again, those are the non-viable eggs in the egg mass. And on the x-axis is the mating treatment. So if they were outcrossing or selfing. And we found that selfers produced more blank eggs. So they had less viable offspring than the outcrossers did, which is kind of makes sense with the inbreeding depression and everything. For F1 size, on the y-axis here, I have centroid, which is just a measurement of size. And on the x-axis is the reproductive treatment, so outcrossing or selfing. And then the colors of the dots indicate the parental predator treatment, so red for control and blue for predator. So we ended up finding that sulfurs were larger overall, and we found also that predation treatment did not influence our size at all of the F1 generation. For the F1, we also found that there was an influence on the shell shape, independent of the influence on the shell size. So what you're seeing in this figure is landmarks on a snail shell. The circles represent the shells of outcross snails, and then the arrows represent the amount inward of the sulfur's shell. So we found that sulfurs had a more narrow aperture. The arrows are moving in so that there's a smaller opening. And I realize this is probably a little bit difficult to see, but this is a GIF I made to kind of visualize. You can really see the difference here when you look at that, how much narrower that opening is getting to prevent predation, potentially. And then moving on to our F2, like I said, we did that behavioral assay. So on the y-axis here, we have the probability that they showed that anti-predator behavior, so the probability that they moved up in the water column. And on the x-axis, we have before and after our application of predator Q. So we did find that predator Q influenced the offspring's movement and their behavior, but it's not in the way that you might expect. We actually found that the snails were less likely to exhibit anti-predator behavior after the application of predator Q, with one exception being the selfing control group. They actually saw an increased likelihood of responding to that cue. For their size, on the y-axis here, we have centroid again, and on the x-axis is the reproductive treatment of the parent, so outcrossing or selfing, and the colors of the shapes indicate the paternal treatment, and the shape itself is the maternal treatment. So what we saw was that the offspring of outcrossers were larger overall compared to the sulfurs, and we also saw that there was an influence of paternal reproductive treatment influencing their size, so they were larger if they had a paternal predator treatment, which was interesting, kind of contrary to similar studies have found a maternal influence in the past. So to summarize our main results here, with the F1 generation, we found that the sulfurs they were bigger and they had a more narrow aperture. They produced less viable offspring, and predator-treated snails reproduced sooner than control-treated snails. And for the F2 generation, we found the offspring of sulfurs were smaller overall. Paternal predation treatment increased the size of the offspring, and the offspring were less likely to exhibit anti-predator behavior and after the addition of Q. So for my acknowledgements, I want to thank Amanda for helping count eggs. It takes a long time to do sometimes, and also Penn State for funding this project. Thanks for listening. I'm happy to take questions. With this project. So I would say with this project, moving forward, I want to obviously write up the data and ensure that we're drawing the correct conclusions here, but I'm interested in the results that we found that there was a paternal influence. Like I said, that's contrary to what has been found in the past, that there was a maternal influence. So I would be interested to do more looking at the differences between maternal and paternal response, or influence, I should say, how significant it is, and the amount that they influence the offspring. Yeah.
So how reliable is the production of the egg mass? Like, you put the two snails together and within day or two? Like, can you see it, or you remove it and then they get large enough to see, and then how quickly can that female produce another egg mass?
So what we would do is we would take the 2 snails and put them into a cup together. We would leave them there for about 3 hours, and we did that twice a week. So within 3 hours, they were able to mate, and after we were finished with those 3 hours, we put them back in their cups to monitor for the egg masses. And it's most likely that they would preferentially outcross, so I don't think there's really a chance that there would be, well, there's a small chance that there would be selfing offspring in the egg masses as well. But yeah, so we would monitor, that way we could see which snail was acting as the maternal figure for the offspring by putting them back into their cups.
So the offspring that were, if their parents have been exposed to predation, the offspring were less likely to show predation defenses?
Yes.
So why do you think that is? Wouldn't it be the opposite? Or?
Yeah, you would imagine that it would be the opposite. If your parents experience something stressful, you would think with that epigenetic information, you should know how to respond to that. I think potentially, especially with the outcrossing snails, I think there's potential that there's kind of that lack of information certainty, so they're not sure how reliable the parental information is. And
Outcrossing, were both parents subjected to predation or just one?
What's that?
With outcrossing, were both parents subjected to predation or just one?
We had the 4 different ones, so in each one, there was 2 of them, one parent was subjected to predation and one was not. And then the other 2, both parents were subjected to either predation or control. So I think there might be some lack of information certainty there with that, because the only group that we did see respond to that was the selfing control group. So they only had one set of information telling them how to respond to that stressor.
So that might be an advantage to selfing.
Right, it might be.
Any other questions? Thank you.
Okay. I'm going to take a 2-minute break.
Yeah.
Long time.
Okay, just because the little timer there, I was worried that I was.
All right. Well, yep, we'll get started.
Okay, yeah. The red-spotted newt has these sort of 3 life stages: larval, then the terrestrial red eft, and then the aquatic adult. And they migrate in the early spring, and then throughout the entire summer. The adult newts travel to vernal pools to breed and also to feed on the larvae and eggs of other species of amphibians. And so spotted salamanders and red-spotted newts are both spring breeding amphibians that migrate with precipitation. You might be wondering why I brought up spotted salamanders in the last slide. It is because the site of my research, Busan, has had this ongoing research into spotted salamanders since 1995. And with this, we found that the spotted salamander migration is driven by climatic cues, with precipitation over the breeding period being sort of a driver of their abundance, and then we see male salamanders and larger salamanders arriving earlier. So Busan is considered to be an amphibian hotspot, but we know relatively little about the other species of amphibians there, which is why we are looking into the newt data. So our hypotheses are that the beginning of the newt arrival will correspond to the beginning of spotted salamander arrival, that they're following these similar environmental cues related to this. The newt daily and yearly abundance will correspond to salamander daily and yearly abundance, so days or years with high salamander abundance will also have high newt abundance. Again, following these same patterns, we hypothesize that larger newts will arrive earlier in the migration and that female newts will arrive later in the migration. So here's a map of our site, and you can see that red box is the experimental research ponds that we are monitoring, but you can also see that there are several other wetland sites in the area that are not yet as well studied. And this is a sort of closer map of the ponds that we've been monitoring. There are these semi-permanent ponds at Busan. You can see that like dotting around them is fencing that surrounds the ponds, and around that fencing there are these pitfall traps that are opened in the early spring with the beginning of the migration. And we open these on nights where there is precipitation, and then go and check them in the morning and bring the amphibians to Allegheny College to be measured and have their body mass and sex are recorded, and then are just brought back to the ponds to be released in their pond that they were migrating to. And so we only have newt data from starting in 2017, and because newts were not the target species, we don't always have complete data on them. So the number of newts that we caught only 2 years were all of the newts body mass recorded, and very rarely were all of the newts sexed, and this is because they weren't the target species, and also because occasionally the newts would be found when we were returning the other amphibians back, and then they would be in the pitfall traps, like when we were returning them. Because of this, there were some concerns that our data might not be representative, but as you can see here, this is the number of eastern newts, the eastern newt and spotted salamander abundance, and you can see that they are pretty closely related, so it looks like our data is representative of the newt abundance at these ponds. So our Going back to our first hypothesis that the beginning of newt arrival will correspond to the beginning of spotted salamander arrival, we see that in most cases they are at either the same day or very soon after, although the peak of the migration for the newts and for the spotted salamanders are not the same, and this is because newts are a more prolonged, less explosive breeder than the spotted salamanders, so while the spotted salamanders will start showing up in March and be finished with the migration by April, again, newts will be arriving at the ponds throughout the entire summer in order to breed, and that's why you see that the peak of the newt migration moves around significantly. Going into our year-by-year breakdown, this is focusing on our third hypothesis that larger newts will be arriving. Shoot, did I not change that? Larger newts will arrive earlier in the migration. We see no real relation in the total length and a very weak relation in the mass. 2018 is the only year that we have where all of the red-spotted newts were sex, so we were able to analyze ratio and size. Very little difference in the average SVL, too much overlap in the average mass. However, we did find a slight difference, a slight statistically significant difference in the average total length, with males being on average slightly larger than the females. And then back to the arrival time. Again, this is the total length and mass by the date. Again, we're not really seeing any relation. 2019 is the year that we got the highest abundance of newts, and this is a year where we saw statistically significant results. As you can see, again, this is the mass and total length greatly decrease over the breeding period, and this is interesting, which does support our third hypothesis that, body size is decreasing over the migration, that they are following the same size pattern as the spotted salamanders. Why are we seeing statistically significant results for this year and not any of the previous years? This year had the highest abundance as well as the longest migration period, so we're getting a more representative sample of the newts. 2020, again, we're not seeing any statistically significant results. There's a very slight, and the same in 2023, where we're just not really seeing very much of anything. And this is probably in part because we were getting very, very low abundance in most of the years. And why is that? Again, the newts are not the targeted species of research. We were also speculating that because of the newt's much smaller size, they are more able to avoid or escape the pitfall traps. Although because of the relationship that we saw earlier between newt abundance and spotted salamander abundance, we think that we are getting a representative sample of their abundance at these ponds, but just that they are not very abundant at these ponds, and that that they are originating from the beaver ponds and the other vernal pools that are across the road. Over this autumn, we opened pitfall traps and minnow traps at these ponds from August to October. And we caught a handful of spotted salamander metamorphs, but no newt metamorphs. Although we did see a lot of newt migration, we did see a lot of red Fs that had recently left other ponds migrating in the road. which sort of supports this hypothesis that they are likely not really breeding in these ponds that we've been monitoring, and rather in one of the other ones. Again, what are some of our caveats and limitation? Again, we've got this very low sample size, we've got this incomplete data where we haven't been looking at the other sort of wetlands in this area. And here's the map where I'm pointing out more specifically, we're thinking that maybe they're coming from the South Marsh or in some of those beaver ponds, and that's more their, where the source population is coming from. Yeah, so conclusions, red-spotted newts are not very abundant at these ponds. They do arrive at the same time as migrating spotted salamanders, but you know, the newts have a more prolonged migration period, that there is a very weak evidence that larger individuals arrive first and that they follow the same relation that spotted salamanders have. This is a graph of the SVL of the spotted salamanders by the day of year, and as you can, with the two different colors being the different sexes, and as you can see, the size of the migrating individuals is decreasing over the migration period. Anyway, next steps, we just really need to do more research on the newt abundance at these other wetlands. We need to have more complete sex and body size data. And we also have to start looking at the emigration patterns throughout the entirety of the year. Normally, we are just focusing on this period of where the spotted salamanders are migrating, but we need to start looking at it over the summer as well as the emigration out of the ponds by the juveniles in the summer and fall as well. And that is everything. I would like to give my thanks to the Watershed Research Conservation. Watershed Conservation Research Center. I'm sorry, it's late. At Allegheny College for helping me with this project, as well as the Regional Science Consortium.
We have time for questions?
Go ahead. Hi.
You had some non-significant trends about the length and the body mass, but on a couple of the slides it looked like even though they were non-significant, the trend for length was downward and mass was upward.
Yeah.
And I'm curious, do you know if the salamanders on their breeding migration are doing any feeding, which might tie into that sort of a trend?
As far as we know, not really. Both the newts and the salamanders, generally, they're migrating not from a very great distance, so they are migrating over like a night or two, so they're probably not eating enough to cause a difference in mass. That could be because of that some of the migrating adults like had eggs and were more sort of ready to release those later in the migration period, but we don't really have, they're not like eating and we don't really know why. You also had a question?
Yeah, I was just wondering, it looked like there was a roadway near the pond. Are you seeing like any mortalities there when they're doing their migration?
Not really, actually. You're right, there's sort of two sides to the property that Busan is at, and there is a road in the middle. During the spring migration of adults, generally they are migrating out of these forests to their closest sort of thing, so we're not seeing any real mortality then, simply because for the most part, the closest sort of pond to them is not
across the road. I will say that during the spring when we're seeing during the fall when we were seeing this terrestrial dispersal of the red Fs, we did see very few that had been, we found, I believe it was 2 or 3 that were dead on the road, but we're not really seeing that during the spring, especially because although there is a road there, it gets very, very little traffic. Not really enough for that to be much of a concern.
Any other questions? Thank you. We're going to take another 2-minute break. However, please note after this talk, at the end of the session, if you're interested in a tour of the Natural History Museum, Mark Letheby in the back will be available.
Yeah.
University at Edinburgh.
Well, thanks for sticking around this afternoon. Thank you, Jeanette. I've been doing my turtle studies up at Presque for 25 years now. I started back in 1999 when I first became employed at Edinburgh and first moved to Pennsylvania. As of 3 years ago, during the pandemic times, I got out and caught my biggest common map turtle that I've caught out of over 2,100 that I've now marked and measured at Presque, 240 millimeters in the plastron length, or the underside of the shell. And to give you an idea of how big that is, I've taken measurements on all 14 species of map turtles. I'm somewhere between 5,000 and 6,000 turtles measured, about 40% of them museum specimens and 60% roughly caught in the field, and she's the second largest of all of them. There was a turtle down in Mississippi, a Pascagoula map turtle that measured 242 a few years back. I'll tell you more about her later, but I thought this would be a good opportunity, a quarter century in, to talk about some age data that I'm starting to see show up. So here's Presque Isle, and I do my work mainly at Graveyard Pond, also in Misery Bay. It's a very happy place. It's much nicer than it sounds. In fact, I have the postcard view of my study site here, looking at the Perry Monument. So this is looking from here through the Perry Monument, and that's Graveyard Pond in the background, and a little bit of Misery Bay right there. Presque Isle gets something like 3.5 to 4 million visitors a year, and I swear I think half of them stop by and ask me, what are you doing with those turtles, when I'm catching turtles? And most people then have a number of other questions, and by far I think the most popular question that I get is, how old do you think that turtle is? And if I have a little one that has growth lines on the shell, I can tell them. If I have a bigger one, I better have a record of it from sometime earlier when it did have growth lines on its shell, or I won't be able to tell them. So sometimes I just say, well, it's at least probably 10 or 12 or 15 years old, but it could be 20, 40, 50 years old also, I don't know. So here's a look at Graveyard Pond. This was my record counting of the map turtles, May 23rd back in 2013. About 10 minutes before I took this photograph, I had passed my binoculars over the logs there near the turtle deck and counted 172 map turtles. So it's 172, give or take maybe 10 or so as they come and go over time. So lots of turtles, and the map turtles have a lot of younger turtles that have growth records on their shell, which fade with time, but they have them when they're younger, and I've been able to get a lot of growth records out of them. Let's see. So here's how I catch the turtles. I have fyke nets that I use that are submerged except for a little part that I put floats in to give the turtles access to air. These are fyke nets out of water that are drying out, so they have a long lead net that leads them in. And then the rectangular traps are basking traps, and I also have some circular ones I use now. So here's some of my map turtles sitting on my basking traps, and I was paddling over to get them and thought I might as well get a photo of that before they jump in to the net. In fact, a few years ago I got to teach summer school, a summer class through Pymatuning, and they wanted us to have it be multimodal, so I had to take GoPro videos of some of the stuff we were doing. So here's a GoPro video of me in my canoe paddling over toward a branch that's just a little bit, whoops, I wanted, start that up again. And so if you watch right there, you'll see plink, plink, plink as the turtles jump into the water. But little do they know that water has a net hanging down in it. So as I pull up, we'll see there's this is actually a repurposed baited hoop trap. Instead of baiting it with dead fish, I bait it with sunlight, turn it sideways, and hang it under one of their basking spots. Now, as I start to pull this up, there's a turtle you can see up there, and we're going to see a turtle just about figure out how to get out of this thing because it's open at the top. Just a moment here. There he goes. Whoops. No, you don't. But there are 4 turtles in there that I will gradually pull out one at a time here. Sorry about the heavy breathing. So that was 2 and 3 here. 3 is a little bit of a biter in the bucket. And then there's 4 right there. Still working on getting 4 out. And there we go. Okay. Oops. So, as I mentioned, the map turtles, quite a few younger turtles, and when they're younger, they have a growth record in these L-shaped growth lines on their shell. So, you come out here where I can see this better. There's the little hatchling scoot it had coming out of its egg, and then at the end of 1 growth season, 2, 3, 4, so that's a 4-year-old turtle. The hatchling scoot on this one is pretty much obliterated, but that would be 1 year of age, 2, 3, 4, 5, 6, and 7 years of age. The males, which are much smaller, hold their growth lines for 6 years. The females for 10 years. After that, the growth lines start getting really close together, and you can squint all you want, but you won't be sure you're counting them right. You know, if I'm reading one as 11 or 12 in a female, or 7 or 8 on a male, I'm always very unsure what I'm seeing. And then I get several where the entire plastron is just worn completely smooth. They've lost all record of their growth line. So hopefully I get them while they're young and then catch them again sometime later. Now, it's sort of axiomatic that turtles are long-lived species. This is a famous article by Whit Gibbons, who's worked with turtles for decades and decades. And here are the turtles compared to crocodilians and lizards and snakes. And this is from captivity data, but it's the same thing in the wild. Turtles live longer, and some individuals are capable of living 40, 50, 60, 70 years in many species of freshwater turtles and tortoises and sea turtles as well. These are growth curves that I did for my Presque data based on a whole lot of females and a whole lot of males. Again, up to 10 years growth lines in the females, up to 6 years growth lines in the males. And one thing that people like to try and do with turtle data is they like to get a growth curve like this and then try to use it to predict the age or estimate the age of an individual turtle based on its size. The problem with this, as you can see, there is a lot of variation at any one age. For my females, some of my 6 and 7 year olds are bigger than some of my 11-year-olds already. For the males down here, some of the 3 and 4 year olds are bigger than the 6 and 7 year olds, or the males. So, and you can imagine it only gets worse. The way the von Bertalanffy growth equation works is it decelerates toward an asymptote that it never quite reaches. And so it only gets worse if you're talking about turtles that are 15 or 20 or 30 years old. There's no telling what you've got based on size alone once it gets into those size or those age ranges rather. These are the data on my map turtle females. Each colored line is one female, and several colors are used multiple times, but each line connecting dots is a recapture history, so these are only the females that I have recapture data on. And at the end of some of the lines, we have ages based on having been captured up to 10 years of age at their first capture and then catching them sometime later. And you can see in the last 4 years now, I've started to get a lot of older ages, including there's a 29 up here and a 28. There's the 29, there's the 28. And then there are some lines that don't have an age next to them because that's a female I originally caught with a worn smooth plastron. So how old was she when I first caught her? Well, at least 10. At least 10, because they keep their growth lines pretty well up to 10. Here's my record female, 240 here. That was 2020. I actually caught her for the first time, though, in 2004. She was 235. She was my record female then. How old was she in 2004? I'm going to say at least 15, but maybe 50. I don't know. I don't know how old she was. At least 15. Look at where some of the 15s are and the 14s and 16s in terms of their size. And she's way up above that. So at least 15, that's a 16-year hiatus between captures. She must have been, I would guess, at least into her 30s. And the oldest known age one was this one from this year, 29 years of age, and her first capture was back in, I think, 2000. Now 29 years of age and having grown quite a bit since then. Also notice that several of these, especially the ones that don't have ages, they're sort of flat. They're not really, they're still growing. They don't totally stop growing at any point in life, apparently. They're still growing, but it has it's been, you know, for some of them, it's been a pretty long interval, like my record female up here, 16 years, 5 millimeters. She's growing about 1/3 of a millimeter a year. Maybe she has a growth spurt and does a 1/2 millimeter one year, I don't know. So that's kind of telling that some of these turtles that I didn't know the age on at first, they're sort of almost, not completely flatlining, but they're coming close to it. Here are the males. The males are much smaller animals, only getting up to, I think 117 is now my record size. But again, I've got some known ages that are getting into the 20s, the younger 20s for them, because I only can tell the age up to 6 years in them, so I don't have any that I first captured that I knew were, you know, 8 or 9 or 10 like I do with the females. And again, some of them are sort of flat, especially some like the blue line up here, captured several times and not a whole lot of growth, but he's been big the whole time, dating back to about 2001, I think that is. So how old was he then? Well, at least 7. And now here it is, 2020, 13 years later. So, you know, that's a turtle that's getting up there in years. Now, I want to show you some data on Calidra serpentina, the common snapping turtle. I got my record Calidra last year, 417, not centimeters, that should be millimeters in shell length, 417 millimeters, body mass 18.4 kilograms, 40.6 pounds. That was the first capture of him, unfortunately. And the other thing about the snappers, unfortunately, only the very smallest snappers have any growth lines that you can read on the shells, that once they start getting any size at all, they completely lose that. So you won't see ages on these two graphs of the females. Females in snappers are actually smaller, males are the bigger ones in this species. So you won't see any ages here, known ages, because I almost never catch a juvenile snapper out in Graveyard or Misery Bay. I think they're probably hanging out across the road in Niagara Pond or somewhere like that. So, but what I do want you to notice is look how flat some of those lines are. Some of them are showing some growth between captures, some of them fairly substantial growth, but most of them are showing very little growth, nearly flat. And so with that being the case, how can you tell anything about how old they are? So in fact, when I caught this individual, of course, that afternoon, I had people stop by and ask questions, and it didn't take long before somebody said, "Oh, how old do you think he is?" And I said, "Well, 15, could be 20, 30, 50 for all I know." After all, John Fetterman is not our oldest U.S. Senator. He's just our biggest. He's not our oldest by, not even close to our oldest, right? He's just our biggest. So maybe this guy is very old, but maybe he's just big boned and not so old. It would have been nice to have caught him some number of years earlier to get a size differential. Now, I wanted to show you just from the literature some records of turtle longevity from people who have been at this sort of thing a whole lot longer than I have. This is actually a couple of researchers who inherited data from people who marked a Blandings turtle in Minnesota. They marked it by carving the date in the shell, and then somebody else recaptured it and carved a different date in the shell. And they're convinced that this turtle that they caught back in the 1980s, they're convinced that back then it was 77 years old at minimum, maybe even older than that. Here's a study of wood turtles. This is me with a wood turtle near the Allegheny River, but this is a wood turtle population also in Minnesota, and age at last capture for turtles have been studied for quite a number of years. They also hold their growth lines a lot longer. So these are ages from growth line counts. And we have several turtles in their late 40s and early to mid 50s in this Minnesota population. So it would be helpful if my map turtles would hold their growth lines for 20 years instead of just for 10. Here's a spotted turtle study up in Ontario. The oldest spotted turtle in this population, a minimum of 51 years old. That was a female. The minimum, or the maximum male age was at least 41 years old, maybe older than that based on its growth lines. Study of the ornate box turtle out in western Nebraska in the Sandhills. And these are all turtles that were beyond 20. I guess 20 was the maximum they could get reliably with the growth rings, and these had gone past that, and either the lines were too close to keep counting them or they wore smooth. So these were all believed to be over 20 years old back in the 80s, early 90s. And then we have ages over here at recaptures later on, turtles in their 40s and 50s. So it helps to be at it longer than just the measly little quarter century that I've been doing things. Finally, another point about this is having to do with survival data that we have from turtles. And so this is one example of survivorship quantified. Again, this is the wood turtle, Glyptomys insculpta. And so we have data from Michigan suggesting 97% annual survivorship of the adults. A couple of New Hampshire studies, 96 and 93, and Ontario, Minnesota, Quebec, etc. Everything in the 90s or the mid to high 80s for annual percent survival. So I said earlier it's axiomatic that turtles are long-lived, but what we're starting to understand is that actually leaves quite a bit of room for mortality when you stretch that out over a number of years. So I put together a slide. Consider a 10-year-old turtle. So whatever the odds are of making it to age 10, consider a turtle that's already made it to age 10, and consider that it lives in a population that has 95% annual adult survival. So 19 out of every 20 adults survives till next year, and one gets caught by a predator or dies during hibernation or gets run over by a car or what have you. So 95% sounds pretty good, right? Probability of reaching age 11 is 95%. Probability of reaching age 12 is 90%. Probability of getting to 13 is 85% or 86%, and then 81% for age 14, 77% for age 15. So now we've almost lost a quarter of those 10-year-old turtles 5 years later, just 5 years later. 20 years, we've lost 40% of them, 60% left. At 30 years, only a little over a third make it to that age. 40 years old, it's about 1 out of every 5. And 50 years old, it's about 1 out of every 7 that make it that old. 75, like that Blandings turtle in Minnesota, at 95% annual survivorship, that would just be 4% of the turtles. And a centenarian turtle would be a 1 in 100 shot just for the 10-year-olds. Never mind what that would mean for turtles at the hatchling stage or the egg stage. And I did it for 90%, and I won't stretch it out, but look how much the numbers drop if it's 90%. 90% versus 95%, that sounds pretty good either way, but these percentages drop off, and like you look at 30 years old, instead of a third, you have about an eighth left of your 10-year-olds. And at 50 years old, instead of 13%, you have 1%. 75 years old, that would be 1 in 1,000 turtles on this survival schedule that would make it that one in 1,000 10-year-olds, they've already made it to, beaten the odds to make it to age 10. And then 1 in 10,000 would make it to age 100. And I did the calculations for 80% survival for 50 years, 1 in 10,000 for that as well. So going back to Whit Gibbons' classic study, these are some of his data from South Carolina populations of freshwater turtles. And what he found in his studies was, yes, there are some very long-lived turtles, but it's a relatively small segment of the population. And I suspect, I don't know what the annual survivorship is for my snappers or map turtles at Presque, but I suspect it's a similar situation. Those oldest ones that are getting up over 30 years of age, they are one out of a great deal, a great large number of turtles that are able to make it that far. So it's axiomatic that turtles are long-lived animals, but paradoxically, it's actually a small segment of the population that get to express that phenotype of their life history to its fullest and live to be several decades old. Thank you.
So say you found one of them wash up mortality, can you age it by internally?
I have not used the techniques of like skeletochronology. From what I've read about it, it would be problematic anyway. You're counting rings in bones, like you can saw through the humerus or the femur. Count rings, but the innermost rings, which are the earliest years, those tend to get broken down and resorbed, so you're trying to account for how many of those are missing. And I think it would be very much an estimate. And that's kind of what happens with like wood turtles and box turtles that can have 20 to 25 growth lines. A lot of people say once you get past 10 or 12 or 15, you're really just estimating age because those growth lines get so close together. And even with my map turtles, like a 6-year-old male, I better have a little hand lens to read those growth lines because he's little and his growth lines, the first 3 are great, but then the next ones, they get really close together. So I think it's more of an estimate at that stage.
Do you have any conclusions about population trends for the map turtles?
I haven't tried to do population estimation. Obviously could with a lot of recaptures that I have. The only problem is the models, one of the big assumptions is turtles don't leave the area and come back to the area, so that they're missing in some of the middle years. And with, I never do trapping like over in Horseshoe Pond or Thompson's Bay, and I suspect that some of my turtles go off over there. Every time I catch a big female map turtle who's worn smooth on her plastron, no growth lines, and she's, say, 220 millimeters, and she has no notches in her shell, no marks that I've applied, I say, well, where have you been all my life? And I suspect it's, Thompson's Bay or Horseshoe Pond, something like that. So some of the turtles are probably leaving for a while and coming back, and I think the population estimation would be a little bit hinky because of that. But I can tell you that they remain abundant. So catching a lot of turtles these days, just like I did when I started back in '99 and 2000.
Have you ever thought about expanding another collection site further into the lagoon system to see if they're just moving around within the lagoon system itself and not necessarily going to the different ponds?
further into,
Yeah, because you always collect like in the corner of your graveyard pond. I
Right.
didn't know if you'd ever thought about going into like Long Pond or off, to see if you would happen to catch any of your.
yeah, I suspect I probably would. I don't see the basking aggregation, so for my use of basking traps, it'd be a lot of paddling back there and saying, no, there's nobody out on that trap, and, paddling back. But I could put fike nets out there. I suspect I would catch some of them, certainly the snappers. The snappers probably go back there a lot, but don't know about the map turtles.
Thank you very much.
Thank you.
All right, that ends our session for today. However, there is food in the lobby. If you go all the way back where the theater is, there is a bar with beer and wine and sodas. And as soon as we walk out there, I bet you the band will start playing again. So feel free to just hang out for a while, get something to eat and drink.